for
it's over already.
applauding Brian and the great work he's doing. But
that's all it is. It's just for my ego.
Yeah. Well, kidding aside, again, a different location for this podcast. The last one I did just a solo podcast. Jim wasn't available to join us for that one, but today we have a very special guest, Ethan Krauss, the inventor, first in flight. Well, I guess his aircraft, the first in flight of self-sustaining ionic wind aircraft. So, if you want to maybe elaborate or correct me on some of the terms I use, and then I guess a very general high-level overview. What is an ionic wind aircraft? And
all right, sure. Yeah. Well, ion thrusters have been around for a long time. There's a type of a rocket. And the thing is, they would produce a very small amount of thrust, and it was thousands of times less than the vehicle weighs. So you get this tiny bit of thrust, about like the weight of a couple pieces of paper pressing against something, to move something that is heavy like a small car. Yep. So no one could imagine them working here on Earth. They were used in outer space, and then more recently, since in the 50s and 60s, people came up with a way to get enough thrust to fly a small model around of ion propelled vehicle, but it required a large, heavy power supply that wasn't on the craft. It was just a small toy. So, and those were called lifters, ionic lifters, and there are a lot of those on the internet.
Yeah, and I was just looking here on my computer, see if I could quickly find one that stood out to me when I originally came across your work. Now, maybe dating back to 2019, maybe even earlier. And I think in 2016, I think MIT had published their first video about creating an ionic wind aircraft where it's designed more like an airplane, and it was launched, right? So it wasn't, starting off from, zero propulsion, right? But then it was able to sustain flight across the gym, which if you look at the flight that they had, it was longer in distance and duration than the Wright brothers' first flight. And, being MIT, they, of course, want to take credit for being the first, self-sustaining ionic wind aircraft. But not only have you been working on it way sooner than MIT, you also have videos that have been public that actually beat MIT to the punch in having this first self-sustaining ionic wind aircraft. So can you kind of rewind a little bit? And
sure.
How did this idea come about, and when did it come about?
Okay.
For you, right?
All right. Well, in the 90s, I was working on small jet engines, auxiliary power units especially. And I asked the boss, I said, how fast do these spin, these little jet engines? He said, about 40,000 RPM. That's about it. And I thought, wouldn't it be cool, if you could make an electronic jet engine? Then you could just, turn it up to speed, as much as you wanted, right? So I had this idea to make a bunch of magnets and coils of magnets, series of coils. And you could ionize the air and make it a little bit susceptible to magnetism, then you could just have like a Christmas tree circuit and, flash the magnets, switch them on in sequence, right? Right. Accelerate the air through this tube. So I tried to do that, and the idea didn't work too well. And then my younger brother is a chemist, PhD chemist at Brandeis University, and he said, well, it would take quite a bit of energy to ionize the air, but you could do it, right? And so anyway, then I found this Seversky ionocraft online from 1964, and it was a big device made of aluminum foil and wires, and it would float into the air with a huge external power supply, these big heavy boxes powering it. That they went to the two thin wires go to the craft, and that was what makes it, where it gets its energy from. So then I tried to copy that patent, and it didn't. At first it wouldn't fly, and I wasn't even sure if it was real. Right. And then I found, well, yes, you can blow air with high voltage. You can ionize air. I found the Ionic Breeze air cleaning device. It was real popular in the 90s and maybe early 2000s. And I actually have one of those in the other room, And So then I started making different types of devices. I didn't show you yet I made these little triangles that are with round holes in them. It's a flat triangle of foil with a frame, and it has little round holes and wires that hang over the holes. And I connected that to a high voltage power supply, and when I got everything just right, it floated up near the ceiling on these tether wire, power wires. So it was very exciting. And that was in the year 2000 or sometime about then. And then I started I used a smaller power supply, got the power supply down to, 10 pounds or something. Yep. And then I got a smaller power supply. I went through, I studied everything that's out there and started, ordering parts and filing on things with a Dremel tool. And I got the weight down to, eventually to 5 grams for a power supply.
So really quick, just from 10 pounds to 5 grams, right?
Yeah.
And what was that timeline like?
In the early probably 2003 to 2005.
Yeah.
I got the power supply down to about 5 grams, right? But that was still at first it was still external,
yep.
Right? And I can't remember if that was with a battery or not. But anyway. So I had a little device that looked like a triangle with round holes and needles hanging over them, and that would hang from a power wire that was looked like a piece of hair, and then another wire going to the bottom of it, and then I had a round piece of styrofoam with a 5 gram power supply on it, and I'd hook up some little lithium polymer. At first, I was using 9-volt NiCad batteries,
okay, yeah,
and they're good for up to 10 amps, right?
Yep.
So I could hit it with 10 amps, and that little flying machine would zip up into the air. And I took it to, at the time I was a student at a community college, and I told someone, and they said, I can't be, there's no such thing. He said, I've seen helicopters and balloons, but no such thing as ion-propelled vehicle.
Yep.
And I said, yeah, there is, I'll bring it in. I said, I brought it in the next day, and he's like, I was wrong. It really works,
Can I interject real quick?
Sure.
Just for the viewers, could you back up and explain, I like to call it the big crayon effect.
Sure.
What exactly is ionic wind power? Explain how does this work?
Okay.
From a real broad...
You know how if you ever reached for a styrofoam cup and seen it lean over into your hand from the static attraction, or you've seen, hair stick to a balloon or whatever, that's a static attraction. And so whenever you have a charged surface, it will pull to a alternate, to another charged surface with static. So these ion lifters or ion propelled vehicles create a static force on a collector surface, and then you have an emitter surface, emitter wire that creates a ball of static around it. And because the other surface is the other electrode, as they call it, is at the opposite polarity, it pulls towards it, just like the styrofoam cup gets pulled by static. And so particles are moving downwards from that. And it can actually blow a little bit of air. It creates a gentle wind.
Which can cause or create lift.
Which can create lift, right. And so if you have a large structure, with built very light, you can magnify that effect. Get quite a bit of wind blowing, and then it took me years of working on it to get it to finally my device in 2006. I had that little 5 gram power supply, and I had a larger structure, a hexagonal spiral structure made of extremely lightweight, hanging from a postal scale, and I connected up the 5 gram power supply, and it jumped up into the air. And then I put the power supply on it and a tiny receiver, and I got it to fly with the power supply at the end of 2006. And so it's very hard to lift something directly into the air with a flying machine with power, onboard power. Right, like the Wright brothers machine, as wonderful as it was, couldn't fly straight up. It would take a lot more horsepower.
Well, and that was, again, even at the time, it was thought to be physically impossible to sustain flight in a manned aviation sense, right? It was just, and I think that's a lot of the hang-up that people have is like, well, even if it's working at this stage, it's never going to be scalable to, provide any real sort of utility. What are your thoughts on that, both from like a timeline and like what's required to really...
I had this book about, this interesting book called Mirror Matter, and it shows all different types of space propulsion. And I've always known that, if you can accelerate your propellant fast enough, that it creates an extremely efficient propulsion system. It's just how fast you can throw the propellant out the back of the thing. So I was working on this it's an ion rocket, really.
Yep.
And I thought, well, if I can get enough thrust to pick, I really think I can get enough thrust for it to pick its power supply up, And I at first I wasn't sure. I do the math, and it would look like maybe it could be done, maybe not, And I just kept, trying different things until eventually it was enough, And so I made the thruster that lifts its power supply with ions. And the thing about ion rockets is they use tiny bits of fuel compared to a chemical rocket. So they get around the problems with the rocket equation, where you have to, you have a bigger rocket takes, more fuel to go higher, and that takes a bigger rocket to lift up the fuel in the first place. So that's why rockets are so huge, and they have to have 1 million pounds of thrust, because
just to get out of orbit.
The math's not in its favor. Right. But with an ion thruster, you could have a little solar panel collecting the energy, and a tiny bit of propellant. And so when I got it to lift its power supply, I was extremely amazed. And nobody got it. They're like, "Oh, what's that? What's the point?" Most people.
Yeah, and I was just quickly trying to pull it up. I can't find it, but some of those out there that are better with Google might be able to find it, or maybe afterwards in the edit we can superimpose it in. The first Ionic wind aircraft flight that I ever saw was the one that the Japanese created, where it was tethered from the ground back in the 1930s. And I mean, it was like this whole big warehouse space, and I don't know the exact dimensions, but let's call it a 10 by 10 foot space or 15 by 15 foot space, just all like car batteries or some very similar looking power source on the ground. Those were all wired together. I don't know exactly the series or parallel in the way that they're wired, but then one tether cable going up to the Ionic wind aircraft, and that's, as far as I could tell, the first ever Ionic wind aircraft that took flight, but again, tethered with a power source.
So you were the first person in the world
in recorded history
who has actually done this with a power supply on board.
On board, right.
Yeah.
Right. That's the significant thing, I would say, or the most significant thing of your...
it required that the thrust to weight ratio be increased by thousands of times. And it required, or at least 1,000 times, and it required that the efficiency of the whole system had to go way up. And so it wasn't easy to do, to make something that large,
ultra light
and light
materials, which we're going to see later.
I'll show you more of a.
And really quick, just for the viewers that aren't already familiar with your content, I'm going to full screen my video. Of course, you're already familiar with this video, Jim. You've now seen the aircraft in person. This is one of your older videos from 5 or 6 years back. So just give everyone a general sense of what like the form factor looks like.
That one was launched hanging from a tether. That one does have a tether, a non-conductive tether that it hangs from, a blue piece of yarn.
Yep.
But the power supply's on it.
Okay.
And this is just to make sure it doesn't fly off in the yard, because again, one of the things that it's like, there's some sort of movie magic or whatever going on here, but it's just, we build like actual like drones for people, and it's a pain in the ass to build those. And that's nothing compared to building one of these. So, I mean, you're saying that it's about 2 months, of very like concerted work, from getting one from that doesn't exist to getting one to where you can test it, right? Is that about right? Or,
right, that's right. It takes a couple months of work, depending on the model. I mean, the ones with steering take a lot more.
Okay.
Steering is not as easy as I thought it was going to be. It's,
not trivial.
Yeah, balancing these things and steering them, they have to have electronic stabilization.
And
high tech,
I do want to rewind a little bit, not the video, but just as far as the conversation. We've talked about steering, and that's actually something that you were starting to work on the last time that I came up here, and we had talked. You were looking at like basically dropping voltage from one section of the aircraft,
Right.
and then that would like cause it to dip. And
Well-
so you've since evolved that, and you're doing more traditional sort of steering that you would expect from a drone.
Well, in 1964, a guy named Major Seversky made the first ion-propelled vehicle that I know of that I had seen yet, that lifted its power supply directly straight to, or not, that lifted itself into the air, not with its power supply. The power supply for his vehicle was gigantic and on the ground. But before him, there was Townshend Brown, who's famous for having a device that would swing around a pole with using ion wind. But he had a huge
Almost
external
like
power supply too.
Tetherball sort of.
Yeah, very much like that. Yeah. So it would swing around a pole. It looked kind of like a flying saucer going around a pole.
Yeah.
And a lot of people don't know that was real, but it was real. Using a dangerous high voltage at high current. So and his power supply boxes, I've seen them. They're like a giant TV from the old days. Like the largest you could get in 1950. So. Anyway, those televisions had a transformer inside that has high voltage, and that's what he powered it with.
And now, so beyond the steering, again, I wanted to show people the form factor here. That's something fairly unique, if not almost entirely unique to your aircraft, where, again, MIT, who, claimed that they were the first, very clearly not the case.
Right.
But they designed theirs more like a traditional airplane, which, again, has trade-offs, right? I think they have not flown, at least publicly so, for as long of a duration as you have flown.
Right.
But I think, just with theirs being a plane, it's covering a further distance, right?
Yes.
But, so as you can see here...
That was MIT.
That's MIT, and that was without the ionic wind propulsion. And now this is with the ionic wind propulsion.
But you have to look at the whole picture too. Firstly, they launch it with a bungee cord that has a very powerful elastic mechanism to launch it. Secondly, it has a grid underneath it, and the grid has a lot of wind resistance. And so when they flew it without the ionic wind propulsion, they still had the grid creating the resistance. Yeah. When the grid's energized, it negates its own drag.
Right.
So what they should have done is tested it, shown how it glides without the grid on it.
And then
put the grid on it and energize it, and then compared it.
How do you think the glide path would have looked?
I think it would have been
like
hardly any different. With that kind of they had a model airplane servo in the rudder and tail of theirs.
Okay.
So you could have shot it up into the air with a catapult, and then as it comes down, you level it out with your tail tail fins, with your elevator, and then it could have glid mostly across the gym pretty flat without the ion thruster. Yeah, so it's not quite clear how much leveling they got from the ion thruster, but it doesn't matter. It was in 2018, and mine started lifting its power supply vertically in 2006.
Wow, yeah.
And then into 2017, mine was flying for almost 2 minutes. It's recorded.
Yeah.
And it's been patented legally since 2014. And again, 2015.
2 minutes to some people may not sound like a lot, right? But again, if you're let alone other areas where 2 minutes is plenty of time, right? Mm-hmm. There's also the case of the Wright brothers. Just looking at where they started, it was dozens of feet. I think less than 31 seconds of flight. Might have
12 seconds.
12, yeah. And then you look at 2 minutes and just fast forward another 50 years. I always it's kind of cliche, but yeah, you got the Wright brothers taking a flight December 1903. By 53, we have supersonic jets capable of dropping nuclear warheads, right? Yeah. Maybe not the most ideal use for aircraft, but it showed a significant amount of progression and relatively speaking, not so much time. And that's what gets me so excited about this is, even going from 2006 to 2056 or, 2016 to
I know already it's going to be much, much better than it is already. And it's already likely to fly for much longer than 2 minutes. And I could see how to maybe make it an order of magnitude better. So in short order.
Yeah, you mentioned with the steering and then in some of the other capacities as well, just the amount of trial and error and the amount of experimentation that's gone into it. And one of the ways I like to tell people about you and the work that you're doing, which I think one of these cameras will be able to see, all of these composition spiral notebooks, those are all notes from starting really a couple years or so into the journey, right? So
right, probably the third, fourth year in there, I think, I started making logbooks, writing down most of the experiments. But at first, I didn't write down a lot of it. I just used them once in a while, And a lot of those have writing on both sides of the pages,
Wow. Yeah.
So
how many do you estimate there? I mean,
between say 125 logbooks. I'm not sure the exact number.
Many dozens. Yeah.
Yeah.
And,
I know it's over 100.
Okay.
Yeah, and that there are a few more in the other room probably, but. Yeah.
And now, what do you think has been like the most? All of it. The integration of all these individual pieces. Because as we've talked about, with the work that we do making drones, we have like one little electrical board that's super simple that we design. Yeah. Everything else is off the shelf components. So, what is off the shelf for you versus what are you making yourself?
Well, back in 2006, in that time frame, I would order this little inverter called a BXA 302, and it's only rated at like 650 volts. It's a postage stamp sized inverter. It was used for lighting on the space shuttle. And but it's although it's postage stamp size and it's rated at 650 volts, it puts out quite a spike of voltage to start a fluorescent lamp.
Yep.
And it runs on 3.5 volt batteries. It was made for that. So I bought that little inverter and I removed all the parts and soldered them back together point to point to get rid of the weight of the circuit board.
Wow.
Right.
Yep.
And I got rid of the transformer shape was called a Drummond ring. It's shaped like a button with a little ring around it. I removed the ring too. So it looked like a little button with some tiny parts. And that little transformer, that's how I made the 5 gram power supply at first. But I had to rewind the thing and change some of the parts to get full power through it. And it would burn out after a short while. But I got enough power pushed through that to fly the first one with onboard power. But it took, like I said, some modifications. About a year, or I don't know. Quite a bit of modifications. It wasn't just off the shelf entirely. And then after that, I started making my own, more of my own transformer cores, grinding, cutting them from special ferrites, and adjusting everything a little at a time.
So it sounds like you're not doing much of anything off the shelf. You're changing anything you get off the shelf. You're modifying.
Yes,
to
everything is made with like a Dremel tool and a lathe and
wow.
Yeah, special ordered custom parts.
Yeah, and just to give everyone a little bit of a visual, I could maybe even in like a second segment when we go out and do a demo, I can show a developer that we have with one of these Pixhawk 6E flight controllers. But one of these, with this plastic casing weighs 39 grams. And I guess to give somewhat of a visual, it's about that big, that tall. And so going back to your aircraft, which this is different than the one that we just saw, but roughly speaking, same form factor, through video anyways. And we measured, we weighed it, and it was all said and done like 23, 24 grams with the battery, with the transformer.
Complete steering, everything.
All steering,
yeah.
So if you're not at the cutting edge of physics or just technology, it almost seems like it's breaking physics with how light it is compared to how big it is, right?
Right. It has to be very, very light. I mean, it follows physics exactly, but it's it's unforgiving that way with what has to be done. Like for instance, the newest circuits I'm making are like BGA 90 pin on a 4x4 millimeter chip. And I'm wiring, soldering wires to each pin, right?
And I think we have a photo.
Yeah, we'll have a photo that we'll be able to superimpose that or share as part of the content.
And with the resonator, that chip weighs 50 milligrams. right? I
So
showed you on
when you
scan.
first did that, I mean, how many times did you quote unquote mess that up? I mean, you had to make a lot of mistakes. I mean, how many,
You know, I really, I wish I
'Cause
did.
we
I
saw
make
it.
a lot
It
of
was
mistakes, but
crazy.
that chip actually, I made only just a few, and I had to rework just a little. I don't know. I used to do aircraft welding when I was younger, and I've been doing this so much soldering that it just wasn't terribly hard. I know the tricks, I guess. You know how to solder without the techniques, how to
the
solder.
pictures that we post, people won't really grasp how intricate,
yeah.
because it's
How small.
when you realize how small it is.
I said, "Can you see the bumps on this chip?" And none of you guys could
Not
see
with
it.
a naked
Perfect
eye.
And there's
vision.
literally 90 of them. We couldn't
there's
see
90
the
solders,
yeah.
90
Yeah.
joints.
Only under the
Yes.
microscope you
Yeah.
can see.
Crazy.
It, yeah.
And then it's clear as day in the microscope. It's like,
Sure.
how can you not see that? You know?
Yeah,
And
yeah.
yeah. And it makes you feel less than human, even though, yeah.
And if I was to remove the plastic and go with what's it called, bare dye technology, right? Just they weld stuff on there, like when they're making microchips, they weld the wires on. You could make it even lighter than that if you had like a microchip making machines. They cost like $100 million, but
Yeah, and then
Yeah.
just get some friends over at ASML or
yeah,
TSMC.
there we go.
Yeah,
Sure, yeah. So I mean, the weight of a flight controller can be, only tens of milligrams, maybe.
Yeah.
Maybe if you go that far with it,
Right. But I want to go back quite a bit further. So you, one point, like all of us, right? Finishing up, or at least high school age, right? I imagine you graduated high school and then you didn't immediately turn 18 and like, hey, I'm going to go invent the Ionic wind aircraft.
No,
right?
when I was, okay, well, this is a kind of a colorful thing, but when I was in the 70s, I was, a young teenager, and all the magazine covers, there were like young kids with hang gliders, and young people were making their own hang gliders and flying off of hills. So I started getting excited by the idea, and I made some hang gliders myself and flew off a hill with it.
As you do when you're 18, right?
Yeah, well, yeah. Nowadays, parents probably wouldn't let their kids, and it's just not. Everybody's on, they're on their phone these days or something.
Right.
But
there's a physical, real world out there that's like outside of the screen.
yeah. So I started learning to build things like that, and before that, I built a lot of structures of different types. And then I made an ice boat at one point, and
An ice boat.
It's
literally
it's
made
like a
of ice?
sled with it's a sled with a huge sail on it.
Okay.
And if you get enough wind, I grew up in Fairbanks, Alaska. It wasn't usually windy, but one day when it was windy, I got on it and went going down the street really fast until I crashed.
So you grew up in Fairbanks, Alaska.
Yeah.
You have military parents, or what?
No. My father was spoke a tremendous number of languages. He was the linguist that made the written languages for the Alaska natives with the help of the elders, and, the Indian elders and so on. And they, so he made because they didn't have written languages back. They don't have pen and pencil
Right.
up in the Arctic. I mean, in the old way back when.
And is that like your heritage traces back to like Alaskan roots, or like?
No, before that it was part of the Scottish and English and White Russian, all kinds of colorful things.
Do you know who the first American generation was in your family?
There were the Parsons on my grandmother's side came over here and started they lived up in Willoughby Hills, and my mother for a while lived in Wade Hill, which is a nice area. And I don't know. It's not really, nothing really to speak of particularly. I mean, I'm proud of them. One of my relatives was an opera singer. And my daughter is a fantastic singer. She must have inherited it from
Skipped a couple of generations.
Yeah, she sings in the sports games when they have like a national anthem singer.
Wow.
She's the one who does it. She's
That's
only
awesome.
15.
And before we got started, and actually, you gave us a little bit of a private behind the scenes tour, and before even doing so, you and Jim were able to connect on the musical front. So can you talk a little bit about that? Is there any crossover between?
Well, yeah, there's, for some reason that seems to be unlike most engineers who go right into engineering, I was into music first. And you don't.
And that started pre-hang glider, or is
no, actually the hang gliding. Well, yeah, it kind of started about the same time, really.
Okay.
About the same time.
What was your first instrument that you picked up?
It was always guitar.
Okay.
Back in those days, the Beatles were on the radio a lot.
Yeah.
And still, yeah, a lot of young people don't know who they are. But so every third guy had a guitar under their bed. They couldn't play much, and I played at one point until I had what are they called, blisters, and they even started bleeding after a while. I was playing, and there was blood on the guitar, because I wouldn't give up. I was very stubborn. So and my brother went to Spain to learn to play. He was quite good.
And your wife is?
And my wife's the best classical pianist I've ever met in real life.
She teaches here
at Oberlin Conservatory.
Okay, wow.
So I lucked out with her. So, but anyway,
just for the podcast, her name?
Elena Loskova.
Elena Loskova, classical pianist.
Yes, she's very good. She has hundreds of videos online. So.
And so I guess kind of bridging the gap between music and your aviation background. So
yeah. So I wanted to tell you the connection there is that when you learn music, you don't just play a scale twice and then say, "Darn, it's too hard," and quit. Yeah. It's not like other things. You have to play a scale, as many times as it takes. If it takes years, you just don't give up. Yeah. And that's how you learn to do iterations. And to be careful, and just when you apply that to engineering or anything you want, you eventually get it, even if it takes a while,
And I guess as you were getting into hang gliding, starting to build those, sounds like starting to get in music at the same time. Did you have a clear idea, hey, I can maybe go a pro music route, or hey, I really like this sort of aviation?
Well, I went to the music route,
Okay.
But that ended up with a lot of years of rough living. So a lot of years of trying to eke out enough money to eat, and there was something important about that. How the music relates to the to the iterations of things with engineering. What was the original question?
Yeah, basically, what path did you end up hey, I'm going to go down the music road, or I'm going to go down this engineering aviation road? And it sounds like, again, really kind of both, but it sounded like maybe music was more of a thought for, hey, let's try to make a career out of this, and then the engineering aviation was
I was always partially into science also.
Yeah.
I always had a thing for science. We had the popular science magazines and mechanics and all that, and there was no cell phones, So I saw on Scientific American they had a pedal-powered aircraft, right? But it looked like a sailplane, like a huge, heavy sailplane, and this athlete was pedaling it. Yeah. And I thought, man, why don't they just use hang glider technology? You could make it 10 times lighter, and the person can pedal it. And I rode a friend on my bicycle, and I thought, man, it's hard to pedal with somebody else on there, Yeah. So imagine this guy trying to fly with a 300-pound bicycle. I said, if you could make it weigh more like 60 pounds, then you'd have a better thing. So I drew this pedal-powered airplane with 100-foot wingspan, right, on a napkin, and hang glider technology with just braced with cables basically, right, and very thin aluminum tubing. And then 3 months later, this guy comes up with one like that, shows it to the public, and wins a prize for $200,000 for flying. I think it was maybe 100 or 200,000.
And what year was this?
That was 77 or
I
something
saw,
like that.
it was a big white. Wasn't he inside of a white?
Gossamer Condor is called. Yeah, it's a stand-up
it's
bike.
Big, it's a big white.
Big wing to Gossamer Condor airplane. So
yeah, I remember seeing that on.
And the early versions didn't have that canopy, right? It's just like a I wouldn't say crappy looking, but just a rough looking hang glider technology,
Very prototypey,
yeah. Very prototypey, and they had a young guy, his son was pedaling it all the time, young hang glider pilot, right? And they really were doing amazing things with it because it's so lightweight, and efficient compared to normal airplanes. So and then they made I before they won the prize, before anybody knew about that thing, I drew a drawing like it, and I said this would work, you know. And then later it came out, and I thought, wow, I can't believe I actually was on the right track. I never built it, but I was on the right track, you know.
And so you went from building or did you end up building any of these hang gliders?
I built a bunch of hang gliders,
Okay.
over the years, up until I was like in my early 20s.
And is this also you here?
No, that's my, I'm sorry, that's my wife.
Oh, okay.
I'm sorry, you probably couldn't see it well from there.
Yeah.
She's sitting in a Russian airplane at the cockpit of a Russian airplane. Her dad's a pilot.
Okay. Well, another connection there, huh?
Yeah, and so maybe that's why she's supportive, because she likes the aerospace industry, you know. And there's a couple of my
I see the patents.
newspaper article. It's flattering, and a couple of my patents, and my electrical engineering degree, and a fake couple pictures of a Nobel Prize.
And now, I thought I remembered that you didn't really have a formal electrical engineering background prior to getting into this work, right? So
yeah, I got it. I didn't graduate with my EE degree till 2013.
Okay, yeah. So you were already 10
Yeah,
plus years.
so I was just
yeah.
doing this to like make sure I wasn't missing anything for my unpropelled vehicle, you know.
Yeah. Wow.
And my family too. They all have PhDs, and I was the one, you know, the black sheep. Yeah, you know. So you know.
And so I guess yeah.
It's great. I love it.
So what was it like? I guess between the hang gliding years and then figuring out like 2001 or 2001.
Well, I also made solar powered vehicles.
Okay.
And they look like recumbent bicycles, but with solar cells on them. But back then, the solar cells cost a lot, so I just used them to trickle charge batteries, you know.
Yep.
And I did that for a while. And I was married to an unpleasant woman up until the year 2000. And then I remarried this wonderful woman, 2002. So we've been happily married since then, and she's supportive of me, which is, I couldn't do it without my wife's,
Right. And
bearing with me,
So I guess now that you've been working on this for 25 years. Yeah.
Yeah.
What challenges have stuck out the most? Like doesn't necessarily have to be technically speaking. I know we talked about some of the miniaturization, and a lot of all of the components aren't available off the shelf.
Right. Well, the Dawn space, the earliest, one of the most famous space ion thrusters. I'm talking about the same subject, but it might not sound like it. But one of the earliest space thrusters was the Dawn spacecraft project, and it accelerates at 0.0000 with 4 zeros, 14 Gs. So that's like a barely, accelerating. Right. And mine can accelerate it closer to 1.4 Gs.
Right.
So that's 5 orders of magnitude faster acceleration than the Dawn spacecraft.
Yep.
Right? That's a lot. And by 2006, the one that picked up his power supply was capable of that. And by physics, by just following physics.
And now the challenge of implementation in space really comes down to just focus, or are there more technical challenges that still need to be broken down for?
Well, I mean, some of the things are that, here on Earth, the device adds electrons or removes electrons from a tiny bit percentage of the oxygen in the air. That's how it works. Yep. And so then once those oxygens get charged, it fills in the valence electrons, then they're attracted really quick to the collector, and that creates a gentle airflow. But so it's a small percentage of the oxygen. But then the airflow isn't too fast; it's pretty slow. But technically, the particles can go from emitter to collector like lightning fast. So in a vacuum, it operates a little differently. The propellant moves incredibly fast. In a vacuum, creates like a beam, but not quite as much thrust. So you need more wattage. So some of the problems with getting it to work in a vacuum are, for instance, in space, there's hotter and colder. There's more temperature extremes. So this is made of polypropylene based plastic on the collector, because polypropylene has half the mass of other plastics. But
and it's one of the most like commonly used plastics for injection molding.
Yeah, it's smoother. It makes nice smooth molds and things like that. But it's
relatively strong.
Strong, smooth.
Yeah.
But it's not. But heat resistant wise, it's like nowhere near as good as Kapton. As polyimide was another word for mostly the same as Kapton. So maybe in space it'd be better to have polyimide, because it would be a little more temperature resistant.
Yep.
And so you have to watch for things like that. And then the cooling of the electronics. Right now I'm using pyrolytic graphite sheets for cooling fins, but I'm getting it to where the electronics aren't going to get hot anymore after a while, so it might not be an issue. This newest transformers doesn't get hot as much. I never mentioned that to you, but.
Now, one of the other aspects that we talked about is the materials, right? And now I know there's some proprietary there that you don't want to get into.
It's mainly just the fine points. I could go over the general,
Yeah. So.
Fully,
Yeah, generally speaking, what sort of materials did you start using? And then, I know you have a few different versions of the aircraft now.
Right.
Can you talk about
it's not just weight savings and smaller electronics. People think, because modern electronics, he succeeded.
Yep.
There's some truth to that, but it's not just that. It's
part of the equation.
It's part of the equation. It's like a key. If you have a key and it has a bunch of little humps on it, if one of them is off, it's not going to open the lock.
Right.
They all have to be right. So, to get the thing to work, you have to materials wise and so on. The geometry is a major factor. Geometry is the biggest factor, and so I tried making little. Just as a few examples, I tried making a craft out of short little tubes rolled like cigarettes, right? And I used to smoke years ago, so I could roll these little tubes pretty quick, and so I'd roll up piles and piles of tubes and glue them all together, and I called them easy squares, and I'd have like a bunch of tubes, make a little square out of tubes, and then I stuck the squares together, and I made this huge structure like that, right?
Yep.
And then, as it turns out, you lose, like 75% of your lift because of all the corners. So then if you put a bunch of triangles together, same thing. And if you have a bunch of, straight pieces like this with ends, all the electricity builds up on the ends of those, and you lose your power there.
Yep.
So the best thing is to have smooth concentric circles, right? Where there's no place for the static to build up a pressure point, right?
And the difficulty there is fabricating
the difficulty,
a circular shape.
Yeah,
right?
fabricate, because you can make one if
Right.
if weight's not an issue, then there's no problem, But if you want to make something that's almost, it's lighter than a feather,
Right, making a rigid circle.
Yeah, then it's tricky.
Yeah.
It can be done with special shrink wraps, and they recently are available online again.
Okay.
The special shrink wrap, but it's polyester, and polyester weighs double what polypropylene weighs. So that's a factor. And then you shrink it, and by the time you shrink it, it's going to have it won't be quite as smooth as straight pieces, and it costs a lot.
Right, and then it's not even just the plastic, right? Then it's metallized, like coating.
Then you have
around
to send
right?
it to the metallizer, because it can't be bought that way.
Yeah.
So you have to have a friend who runs a metallizing company and who can do exotic, coatings.
And that's something that I don't think most people are even familiar about, that you can get like metal coated plastic, and again, you might think, oh yeah, that makes sense for, I don't know, something like, I think that's solid metal, but pieces like this. But when we're talking about the frame or some of the pieces of your Ionic wind thruster, it's much more malleable than like a sheet of aluminum foil. So I mean, it almost seems like, again, you're not with materials physics and the latest and greatest in technology. It's like, wait, this is metal, but it's again.
Yeah, it's only angstroms of metal on.
Right.
It's the coating is like nanometer, measured nanometers.
Right. It's like the Georgia State Capitol building. Right. It's like all gold plated, but it's like some like microscopic amount of gold that shows.
Yeah.
Because gold you can almost like infinitely spread, not infinitely, right? But I mean it gets very
incredibly thin. I mean, if you hold the gold metallized material up, you can see through it.
Okay. Yeah.
It's what they put on like helmets of the space early astronauts' helmets,
And now, can you talk about some of like the differences between those materials, like the different types of like metallizing?
Sure.
Like
well, there's silver. I've got gold, silver, and aluminum. But the aluminum oxidizes, so it grows a coating over it, and that prevents it from conducting with the air. And there's a whole lot to that, right?
And so that basically like manifests in it like losing effectiveness. So you again spend a couple months, building one of these aircraft. You get videos, you do some demos, and then really nothing else changes to the aircraft other than it just sitting there. And then over time, it can lose effectiveness.
Yes.
In some cases, not be able to take off over
That's right.
that period of time, right?
Yeah.
So can you talk about like what the process was like? Starting with those first, plastic with aluminum material.
Sure. Let me say a few things. Number one, at first I was doing spirals, hexagonal spirals, right? Not with the material that I also made spirals that are smooth with the shrink wrap stuff I was telling you about, the expensive stuff. But I had to take that to the ready-made spirals to the aluminizing guy, and he would coat them with aluminum for me. But that's a whole project in itself there. But so I made hexa spirals, with straight segments. And then I noticed that when I hooked the power supply up to the inside of the coil, that most of the wind would be blowing there and hardly any on wind to the outside edge. Right? So I thought, well, I'll put jumper wires between all the rings, so that I can guide the current to the outermost, so it'll blow evenly across the whole thing. Yeah. So then I did that, and then I thought, well, why am I using since I have to have jumper wires, why bother to have a spiral, hexa spiral? Why not just have concentric hexagons?
Right. It's
much stronger, right? And I have to have jumper wires anyway to connect them all together. Am I being clear?
Yeah.
Okay, so that's why it evolved into concentric hexagons, right? And then, and of course, the original ones were all smaller, right? But I had to make them larger and larger to get more lift with the same current. It's kind of like the human-powered helicopter thing. You have to have a huge propeller to fly with just a human pedaling, right?
Right.
So it takes a lot. The large surface area gets much more lift. The human-powered helicopter produces about 100 grams of thrust per watt, whereas a regular helicopter is more like 10, 15 or something like that,
Right.
So it's 10 times more thrust per watt. So that's why I went from hexaspiral to concentric hexagons. And then the connecting to all those, to aluminized materials or metallized materials, whatever coating you have. Yep. If you put the wire you can't solder to it, right? Because it's angstroms thick metal over plastic. Right. So soldering is out. You can use conductive epoxy to hook a wire to it, but as soon as the epoxy dries all the way, it breaks the coating. You get a crack all the way around where the spot of epoxy is, right? Conductive epoxy. So then if you use tape, same thing. When the tape it lasts a little longer, but then when the tape starts to dry and adhesive dries, it all comes loose. So you have a whole bunch of bad connections and an unreliable thing to show. Okay. So finally I found this, I hope that I put it in my patent and it's public, but I think I did. I found if you use extremely small magnets, and they're very tiny, I can't think of an analogy. What's that small, the round, disc-shaped?
I can think of something that small.
Yeah.
Speak for yourself.
Yeah.
But little tiny magnets. So you put one on each side of it, and it clamps together, and you have the wire soldered to that tiny magnet. You have to do it really quick, or that kills the magnet.
Yeah.
Or you can glue them, but I usually solder them just real fast.
Yeah, that's kind of similar to making battery packs. You know, you can solder like the tabs together that are typically supposed to be spot welded, but then you can heat up the cells if you use a soldering iron. And it can blow up the battery, or just it like crystallizes on the inside.
And you use larger batteries too, so it's even more dangerous. But that's a good way, you know.
But yeah, very similar. That you would think that soldering, would
good
work,
solder. It gives a powerful solder. A flux, a powerful flux. So so it's quick,
Yep. And then you talked about the aluminum oxidizing. You tried out then silver, right?
Silver, but it tarnishes.
And it tarnishes.
And they said, oh, but pure silver won't tarnish too fast, but it's still tarnished. And no matter what you do to the environment, and if you have a little piece, you could put a special bag around it and everything, and it'll last for a couple of years. But not
Mother Nature goes undefeated. Yeah.
So I spent since ChatGPT came out recently, I spent a long time asking ChatGPT, what can I do? I spent weeks talking to ChatGPT about it, and it was all bad ideas. So.
All right, we heard it. We heard it here for the first time, everybody. ChatGPT,
Doesn't
bad
know
ideas. So everybody remember
that. It can help, but it's mostly bad.
Right, and it's for well-documented, established content, and even then, it can be misleading, for lack of a better way to put it. But yeah, even for some of the work that we're doing, which using established programs, but they're still really popular over the last few years. And so talking 2022 or more recently, there's just not a lot of content information that ChatGPT and some of these other platforms are pulling from. And it's basically if we're needing to do drone setup or configuration, modify parameters for one of our radios, ChatGPT is practically useless there. And I can imagine there's not a lot of content that it can pull from for, hey, I'm building an Ionic wind aircraft. What materials can I use? How can I improve?
Well, it's a wonderful machine, but it can. It doesn't.
It doesn't think for you.
Yeah, it's just a.
It's an idea generator.
Yeah, it's really helpful for writing things. If I know all the details, but sometimes I have so many details to try to communicate that I can't get them organized.
Right.
And it organizes speeches and things like that very effectively, but you still have to do the experiments.
Yeah, that's something that we do a lot of software development for our drone control software, and then we'll do software simulations, and then you get out to go test it, and it's well, we did all this in software, so why do we even? And then we go out to test it, and it doesn't work as it did in the simulation, and it's you can do all the simulations that you want, but until you actually get it out to test,
physical experiments.
I want to say it's not all for naught prior to then, but practically speaking, right?
Yeah, nothing's as all math in the world isn't as accurate as measuring something.
No,
generally it depends on how.
That actually, and we can steer it back to more tangible, especially around your work. But how do you think about math being someone that obviously from an electrical engineering perspective, very important, but I think a lot of people will try to use math as almost like a form of religion for describing the universe, right?
People use it to sell, and they use it like a religion.
Yeah.
And it's math is an interesting thing, and it's a useful thing, but physics, I would kind of, in a way, physics beats math, because there's always a creative way to do something. Math says that's impossible, There's only 5 gallons in that tank. You can only go so far. Yeah. And always things can be mathematically impossible, but not physically impossible.
Right.
Because you could, what happens if you got a tailwind? Wait till there's a tailwind. Then you'll get better mileage, Wait till, pump the tires up extra, then you'll get better mileage. You could keep doing things like that till the cows come home.
I feel like with math, there's maybe not an infinite number of variables that can't be factored into equations again for explaining the universe, and it's I don't get, to your point, the hang up of like, well, hey, let's go like create this theory of everything, based off of a math equation. I think that's fruitless, right?
Maybe.
But again, what do I know, right? Yeah, but
well, we're all just, we're not even a microbe compared to the universe. But I mean, I was going to say about the math and the physics of making things possible, and the main equation that ion propulsion is that people use all the time. The force is proportional to the current times and the distance, right? That you give to your ion propelled vehicle, and the current is not really a good thing to relate your thrust level to, right? Because you could have jumper cables, they have like 800 amps or whatever it is, I forget the exact number, and you have no ion wind,
Right.
But you can have microamps and on a point of at 100,000 volts and get tremendous ion wind, right? So it's not really, the current isn't really. Now it's true if you have a thruster, an ion thruster, and you can't move your emitter wire, and you can't move your collector, and you set them at 2 centimeters, you can only put so much voltage before you get a big spark, right? So there is a limiting factor, and you turn up the current, and it'll draw more current, according to the distance of the voltage. So it's true in a way that it's proportional to the current, the ionic thrust. But generally that's just all wrong, and everybody goes with the thinking they just need more current. But you can't make a light power supply if you need 500 amps, and you can't, and you're not going to get a lot of thrust either, depending on the geometry. It's mostly geometry that controls your thrust.
Now, have you looked into any of the other forms of like alternative energy aircraft out there? Like, there's this like Russian guy out there, like Alexei.
Yeah.
Something.
As far as I can tell, I can't see any reason. No one who's done anything like that has been able to prove they got a milligram of thrust. Not even a milligram.
Yeah, let's see.
You know what I mean? There's no evidence. I mean, there's a video that looks convincing, but there's no evidence.
There's some that
physics.
look not so convincing, right?
Yeah, and in his other videos that you could see are clearly hoaxes. So he's a known hoaxer, and he's doing something that there's no physical reason to believe him at all. So I would say, until he comes up with, what's that guy that used to have the science show?
Bill Nye?
No, older.
Neil deGrasse. Carl Sagan?
Yeah, Carl Sagan.
Yep.
He said that extraordinary claims require extraordinary evidence.
Yep.
Right? And if you've got a perpetual motion machine, you're going to need, that's a very extraordinary, you're going to need a lot of proof, to make people believe. And it's right not to believe as someone if they can't show you why,
Yeah, let's get through this ad really quick. And I do just want to share it, even though, again, I go back and forth on not whether or not I believe in it, but...
Or leave it up in the air.
Yeah.
At least leave it up. Don't just accept it because...
Right.
The video looks like it could be real because people can make fake videos. That's the problem I have now is that there's so much AI and everything. Everybody's going to think I'm an AI person.
Right. Just
or I'm real good with movie magic. But this is not. This is the real thing.
And that's something. Even though what we're doing is much more basic, I worry about is like how can we just show it within one video that it's not like cuts where people they edited that in some clever way and. One of the issues with this, I guess, is it's also like very high voltage, so I guess it messes with the camera. And this is the case of multiple videos.
Kill the audio on that because I can hear whine.
Yeah, there's several reasons why I thought that was fake, but I haven't analyzed it in a while. The way he kicks things, the way it hangs, the fact that there's no physics.
Published about it, or
he's got this metal that you buy from the hardware store that has bumps all over it, and the fact that it's so low powered and so much weight. There's just too many reasons, that I don't think. Oh, when he puts a ring over it, it's one of those rings you can open and close, like this, and it goes out of the camera and like that. You know what I mean?
Yeah.
But there is on the outdoor one, he goes like this, and then on the other side, and on the other side.
Now, do you speak Russian at all, or
almost none.
okay?
So
have you ever asked Elena to watch any of these?
she,
videos?
yeah,
Like,
she translated at one point,
Okay.
but she.
I asked one of our Ukrainian Russian interns to do the same.
Yeah. But there's nothing really too revealing. It's just.
Right.
It's just.
Hey, this is where I'm plugging this.
I think it's. I mean. If I said, if I came up and said, look, I have anti-gravity or a perpetual motion machine, look at it, and it really works, and here's a video of it, and then I didn't show you exactly how, then you shouldn't believe it, That's what I think. Or you should say, well, I don't know, maybe not.
Yeah, and that's from what I've understood, like, he doesn't even understand necessarily how it works, but again, that could just be...
Well, it can be, and it can be that, it has to be repeatable. Well,
right.
It might only work, once in a while.
Right.
That I don't...
We both know that, yeah.
But the thing is that a transistor might, you get it working, and it's working, and then it burns out, and then you can't... And it takes you a year to make another one that works the same, That could happen.
And I think there's also something that you experience. I've experienced this where like, oh, I've already done that. So why do I want to do that same thing or maybe that same thing, but just a little bit different, again,
Sure.
right? Versus moving on to the next one. And I've heard something along those lines where he also has like a version 2 that he's been working on. So that's why he hasn't focused on replicating this one. And
well, he's sold kits to people.
Okay.
And, I've been looking into these sorts of things, right? And there's there's an ion thruster called Undefined Technologies ion thruster.
Yep.
And they had 2 public patent applications, international patent applications. One's for a, a ducted fan.
Yep.
And the other one is for a heated cathode lifter. But the heated cathode lifter was online. It's all smoke and mirrors, the thing. It's not real. It's real ducted fan, and he's got and it's computerized simulation stuff.
Do they still have that old video?
Computerized image. I mean, it's just, he had an ion propelled vehicle that was really ion propelled, and it. Yeah, you can hear it. I mean, it's a ducted fan spinning up. Right. That's a ducted fan.
So basically, it has ionic wind components on it, but they're not actually usable enough to actually generate any lift or thrust for this aircraft.
Even if they work, the aircraft.
Then?
So just
it's a ducted fan in the middle.
Right.
Well, it's a typical. There's a thing called Icarus.
It's almost like a hybrid, right?
Yeah,
Okay.
There's a thing called the Icarus ducted fan flying. That was the first one that I'm aware of, and it's just a ducted fans, which are super high powered, like leaf blower motors basically in a tube. And the guy made one online that would fly and got it to stabilize after a lot of, messing around with it.
Yeah.
And that's what that is.
Do you think your technology will first enter the marketplace or more general use along in a hybrid scenario versus?
Well, no, it won't be hybrid. The thing is mine's about to be a whole lot better, and but the thing is that it's the only one that really is really ion propelled and it's real.
Takes off itself.
And it takes off and this is power supply.
Yeah.
The other thing is is almost like 99% chance, 99.9% chance that Russian one's a hoax. There's a 99.9% chance, and I'm being nice about it, or okay, who knows if I'm being nice? 99.9% chance that the Undefined Technologies one is powered by a ducted fan almost entirely. So, your original question was it?
Like, say for gliders.
Will it be?
We
Will it be hybrid?
Earlier during that maybe the technology could be used in gliders
Right.
to help
Well,
them stay afloat.
Well, here's the thing. I mean, ion thrusters make the ultimate rocket. You get around the rocket equation, the limitations from the rocket equation in a sense. And so you could accelerate continually, very rapidly for a long period of time with ion thruster, with a special ion thruster like this. So it could go, it could make incredibly rapid space travel possible. It could make going to space with just a small lightweight device could go right into space. And so why would you want to push a glider, which is like,
Yep.
the ancient technology?
To get to Mars right now would take us, what, a year or two, a year and a half, something like that?
Well, this would be like,
this technology,
like days.
It could get to Mars a lot faster.
Right. So, I mean...
and that's how I see the...
Yeah. I mean, why do you want to, take the most advanced space thruster, basically, it's the most advanced thruster, and push a glider, I mean, it's true. It's much easier to push a glider. You can have if your glide ratio is 50-1, which means you go 50 feet forward for every foot you drop, or every 50 units forward for every unit of measurement you drop. That's a really good glider, right? Then you only need about maybe a 50th of the weight of that structure for thrust to keep it level, right? Yep. But to go straight up in the air, you need more thrust than the thing weighs. So once you can do that, then you have potential to go to space with rockets. But you've got to carry propellant then, at least part of the way, and but only tiny bits of propellant.
Right. Yeah. I'm just thinking you would be able to hop on a glider and fly it for a long distance.
Yeah, with that's true.
With the
there are advantages to mixing them. I don't mean to say there's no advantage. But
you're not interested in that, though.
I have higher hopes, and that's why I succeeded.
You're shooting for the moon.
Yeah, I'm shooting for the stars.
The stars,
and that's why I am able to make things. I'm serious about making things lightweight and making the best materials I can get and everything else. If I just wanted to make a glider, I probably wouldn't have succeeded. It's not exciting enough for me. I don't know. It's just It's
really you're not trying to solve a problem to help mankind. I don't mean to get too far out, but you're not interested in this from a commercial standpoint to make money or you're looking at this as with a larger.
No, I like the idea of making money, and it's kind of sad because I haven't made a lot of money yet. But it's just that I don't do it. It's to help mankind. Like it sounds pompous, right, to say that, but I was kind of raised to think that way. That's the point in being alive, right? Well, at least from my family's mindset, is to try to do something while we're here that helps mankind. Even if it's teach somebody to play music better, or clean people's houses. I don't know, whatever. Just you're trying to help mankind somehow. It's not just to get your pocket full,
right.
Or the next 6-pack of beer. For some people,
it's cliche, but it's like you can have all the money in the world, but it's like, what are you doing with it, right? And it's like if you don't treat it as a resource, like for me, I wouldn't want billions upon billions of dollars like I do want, but it's because I want to make passenger drone aircraft.
Gold-plated palace,
Well, no, like...
Why not?
You're not doing it to try to make a lot of money. You're doing it for...
Well, and I do say, like, I didn't start AuHu as a non-for-profit or non-profit or not-for-profit either, right? So, I mean, it is, like, for at least my mind... thinking about how we can, at least keep the lights on while we're actually trying to produce our first mass market product. And then our mass market product, that's what's going to allow us to then make more mass market products. And eventually, I hate to say that, but let's say within the next decade and a half, or maybe two, working on passenger drones that we can also start then working at a mass production scale, making it more like an automobile. And that just, the reality is, costs tens of billions of dollars to even get started. In any sort of...
Well, you could do it for less than that. You can do it. There's a guy who's doing it on, shoestring budget.
Oh, again, getting started.
But he didn't succeed yet.
Right. Well, and there's something to be said, like, we need to get people used to the idea of smaller, more personal assistant drones, using them as part of their everyday lives before it's like, hey, let me go send a package for, using my drone that I have at my house, or to send my drone to the local Amazon locker, fast food restaurant, retail store, or hey, I have a package I need to return to Amazon. Instead of driving it out, you send your drone out to
It's going to be wonderful when we get packages faster from Amazon.
Or even from other kind of leveling the playing field to where they don't need to all come from Amazon, right? Because now every local business can offer point A to point B delivery services as long as you, the consumer, have your own drone in the same way you would use your own car for like a curbside pickup, right? And I think that's the real unlock before even though it's already happening in China, you can go over as a tourist, get in a passenger drone, travel across some of their larger cities. We need to get people used to the idea of like, how can I use one of these to get my cargo from point A to point B? How can I go get information, from this remote location without me having to go there, right?
It takes a lot of programming to get that, a lot of sensors and programming. And I try to avoid the program as much as I can because I don't like it. But a lot of it's pre-done. It's more configuring,
Right. So can I ask this? Yeah. Let's just look in the crystal ball and let's look 50 years out from right now. Where would you hope that this technology? Do you have a vision on it, or how do you share with?
Well, for the short term, I can't break the physics that I can't align the physics well enough to make it lift heavy weights for the short term. I mean short, like quite short term.
And that's like materials, electronics that like theoretically exist or technically speaking exist right now, but just in a way that you can get your hands on for anything short of millions of dollars, right?
Well, what I'm saying is, like in Star Trek and Star Wars, everybody flies with ion propulsion.
Yeah.
Most science fictions, you see blue glow behind. That actually represents a loss. The blue glows, but there's still. I mean, if you have that much, high enough, concentrated enough power supply, it might create a bit of a blue glow.
Yeah.
So in that case, to make it happen like that, like where you walk and step into a transport and it's ion propelled and it lifts people up, is not really. It's not out of line with physics. The physics say that that is possible, but I don't know how to get that much thrust in a small area without losing efficiency yet. But there are so for the technology to do it is. I'm about to make it 10 times better, maybe, no promises there, but I think so. And so the stuff that you can get for hundreds of thousands is there.
Now, are you familiar with like this concept, and I could be butchering it, there's like these like nuclear diamond batteries?
Yeah, I forgot the name, but I can't remember the trade name, but they've been around for a long time. Well, not necessarily diamond, but there have been something voltaic.
Yeah, beta voltaic.
Beta
device.
voltaic. Yeah.
And so, is that something that's applicable here? At
well,
all, maybe?
The problem with those is they last for decades or whatever, but they put out a very low current for decades.
Got it. Okay.
But with mine, you need the most current you can get with the least weight.
Got it.
So just as input,
So, but is there anything maybe similar? Some of the more kind of out there aircraft that have been designed and prototype test flown have been like nuclear powered. It's
possible.
Okay.
It's possible, and there are already made solar cells that are so light they're like saran wrap. You know what I mean? And you could put a piece of that on there, like a membrane of solar cell, and it would fly all around as long as the sun's out. It would fly.
And now
or accelerate.
A lot of this, goes back to what we were discussing with having to make your own components, own electronics. A lot of the electronics that are off the shelf, that you can modify, have come from really the industrialization of China. Is that something that you're concerned about at all? Where like our reliance as a country, even for like the work that you're doing?
Well, I don't think we can copy the Chinese, anytime soon. I mean, they've been Chinese, the Japanese, the overseas. There's people have been working, crafts people been working on for 30 years. Making the perfect sword or whatever. Right. And you just can't expect America to be able to make batteries just as good, identical quality overnight. Those things take years to develop. A lot of tradespeople, hundreds of tradespeople sitting and talking and developing things, so batteries I get are typically from China.
Yeah, I was listening to this guy, I think a Chinese American, and he was talking about what we've lost in this country is the actual physical infrastructure and some of the workforce, but and it kind of goes hand in hand is the kind of intrinsic knowledge or intrinsic information that you can't really document, right? In some cases, it just comes from like actually day in, day out doing experimentations, collaborating with other people, and we just don't have a lot of those environments, you know.
You know, like you take some dude that's that's been working at 65 and he's been working in a transformer factory,
right?
Making a huge variety of transformers for 40 years. You know, he's going to know more than somebody who just
well, and
read a book and got his degree. You know?
Well, you can even take that guy, right, and tell him, write down every single step for the processes that you oversee, and then translate that over to someone else that should be fairly competent to.
But it's a little
right. It doesn't translate from here's what you're actually doing to here's what you're doing to paper to then someone else reading it from paper and then actually doing it. In
like a basketball player, he can write you a book about it, but you're still gonna fail on the court. You know, it's like the basketball player's gonna. You know, what's it called when you can throw a basket across and make it into the hoop? I don't know. Slam dunk or whatever. I don't know. That's different.
3-point, 3-point shot.
Something like that. Yeah, you can't make the 3-point shots without the.
What are your thoughts on new innovation with technologies like things the Wright brothers didn't know about? The internet.
The Wright brothers solved the stabilization problem. That's one thing MIT wants is credit because they made one that stabilized. But the Wright brothers solved the stabilization. They have a patent for stabilization of gliders, And so they can't really say they're like the Wright brothers, They could if I didn't exist, but I do, So,
basically outside of the scope of what you maybe work on day in, day out, or by and large with Ionic wind aircraft, are there any other like technologies if you weren't so consumed with Ionic wind aircraft that hey, this is maybe
new technologies.
Yeah.
So with the Wright brothers, about new technologies and challenges, and how things all relate there with the new technologies. So the Wright brothers had to have like 3 times the thrust that you'd get with a normal engine made of steel. So they made an engine out of aluminum, and it's like 3 times lighter. I don't know the exact number, but 3 times lighter, and that enabled them to have the thrust-to-weight ratio they needed. And then they made, they did all those other experiments. But that was their problem. The Wright brothers, it was stabilization and a little bit of power-to-weight ratio. That was their problem, right? The problem with ion thrust is to have, huge, the Dawn spacecraft weighed 10,000 times the thrust it could produce, So the problem there is thrust to weight. The problem with get an ion rocket to go straight up was all a thrust to weight issue. And so then like the new technology, but now with computers, for instance, this is all related. I hope you can see I'm relating it. So computers, used to fill up a whole room, right? And now you got the whole, a whole building of computers on your iWatch. Right?
Or Huawei non-Chinese watch.
Oh, hey, like a bargain version. Wow, Jesus.
Yeah, it's actually version 1 of the Huawei watch.
Wow. Yeah. So you've got that whole building worth of stuff shrunk down into next to nothing. And that is one of the things that makes ion propulsion easier to do. To have electronics be shrunk so incredibly much. And so thousands of times improvement. And so, the new solar cells that are coming out, new nuclear types of things that are coming out.
I mean, 50 years was my earlier question. 50 years from now, what new technologies might change this whole picture? That's kind of what I'm I'm going.
The future of the technology.
The future of this technology.
Rather than the present or the past.
Oh, yeah.
So the future, you could have... something that's almost all energy instead of weight, mass. You know what I mean? Like a structure, ion propelled vehicle. It's got an incredible amount of energy and hardly any mass. You know what I mean?
Actually, speaking of which, now I've talked with an advisor type guy that I've worked with. Very brilliant electrical engineer. Also does like software development, like at the firmware level. For semiconductors and processors. We've talked about this idea that you can have like emitters, spaced out around the globe and basically create these plasma balls anywhere around the world that you can almost like control like aircraft.
That would be freaky.
Do you think there's anything like that out there, or do you think that's...
I could imagine it for a shorter distance, but I don't know from far away. I don't know. I didn't even know how to make a plasma ball too well close up, other than throw something in the microwave, the wrong thing. But you know, but yeah, it's fascinating, interesting thing. Things. What would that be used for? You know.
So really, as a weapon, I think it was like a DoD, like DARPA sort of project.
That's kind of horrible. Yeah, it's kind of a horrible thing.
Well,
there's a lot of weapons that are, you know.
There's the DARPA EATR, the Eater robot. Have you heard of that one?
Maybe you've heard of it. I can't recall what it is.
This DARPA robot, it's fueled off of biological matter. So the idea is on the battlefield, right?
Oh, no.
When you have a lot of biologic...
It kills you and then eats you.
Oh no! Well, I saw a movie like that.
Already dead matter.
The Langoliers. There's a movie called The Langoliers. It's about a plane that goes back in time, but then these creatures come and get rid of everybody.
Brian's familiar with every movie.
It was a made-for-TV movie.
It was really cool.
Yeah.
But it's similar.
It's just these big mouths with these teeth that would just eat reality.
Yeah, it gets rid of the wrong past or something that's not supposed to be there, you know. So it was an interesting movie about a plane going back in time, but then it turned into, you know, these things come and eat everybody, you know.
Yeah. The one thing that you might also find interesting, this guy, he created this plasma cannon. And again, I don't know what really the practical use case is other than a weapon, but this is one of the other... yours is up there, maybe at the top of the list, and then I would put... him right up there.
Can you send that to me at some point?
Yes, I will.
At your convenience.
Yeah.
Jesus.
But yeah, he was talking about being involved in like this early version of like a BattleBots type of competition.
I built a Marx generator, like a small one.
Okay. Yeah. And he was talking about like some of the limitations.
Oh my God.
Of having like.
Wow.
Yeah, he was talking about some of the limitations of the capacitors that were available at the time back in like the 80s when he was working on like those that robot fight arena organization. I forget the name of it, but now he was able to get enough capacitors, but still just to build this machine, a few $100,000.
I see why you're interested. Why this is interesting. This is cool.
Yeah.
I must say.
But yeah,
this is very destructive.
Yeah. But this is like we're getting closer and closer to like understanding, not just understanding physics, but being able to harness physics in the form of engineering that it's almost like godlike, right? Like, because think about, you know, like he's literally creating his own lightning. And that's something that's still like not really well understood. Like how lightning is formed, like where all that energy, you know, like what's the catalyst for, you know, that energy. And it's really kind of like flight, you know, like we have, you know, Bernoulli's principle and we have like this basic, you know, graphic for like how lift is created. But like there's really still not like a really good understanding for like how airplanes fly, right? And I think this is.
I mean, you can have a whole wall of, you know, you know, you can have a whole wall of articles about what the air is made of.
Yeah.
And how the electrons move in it, and how the particles move, and the Brownian motion, and the, you know, the distances between all the molecules, and so on. You could study a whole wall just about what air is made of, and how it works, and so how much moisture is in it. You know,
and never get to the bottom of it.
And never get to the bottom of it. You know, and you can't even find one bit of it on Mars, for instance, right? You know, one breath of it, you know, it'd be like, oh, what a wonderful find, you know. And my kids get upset sometimes, my young daughters, and I say, look, you know, you're lucky to be on a place where you actually have air to breathe. And I said, if you just knew everything about air, you wouldn't be bored if you knew how much there is to know, even just about the air you breathe, you know.
Yeah, that's much more extreme version of what I like to say is like I grow up and like still like if you have food, food, clean drinking water, and a roof over your head, you have no real problems, right?
Yeah.
But especially in the case of business, it's always like, and Jim, you're kind of getting at this, like what problems are this addressing, or even like how is this usable? And yeah, like that is important. Of course, if you want to like commercialize the product, but at the same time, not everything has to necessarily be done for, how is this going to
Your
create
retirement.
some yeah, right.
For your
Like it's
retirement
like
plan.
for humanity, like you're saying, how can we do something that like gives us a better understanding, across humanity, and like again, maybe not everyone takes advantage of it, but it's still like just doing your little part that the next person can build on top of, right? And I don't know. Maybe.
Do you care about your legacy, or is that something that's I would imagine that's not important to you.
Well, my family and me, always cared about, we'd like to. It's important that we are known for doing up to good things,
Right.
Right. Being more creative, not destructive.
Yeah, not destructive, up to good things, legacy and so on. But
50 years from now, you may be considered a father of Ionic flight, right?
Yeah.
Or
some people
founder
are
of-
saying that already, but
people
it doesn't
are-
do any good.
yeah.
When they took Orville to see that statue, not statue, pillar, what's it called? Monument is the word.
Monument. Yeah.
He looked pissed. He didn't look happy. He was like, "Yeah, gee, thanks. Finally made a monument." He spent his whole life in court and not getting paid properly, and people trying to rip off his stuff, and he wasn't getting paid like a normal person that works every day. You know what I mean?
Yeah.
And it's people don't, there's a few people like yourselves that appreciate this kind of thing, but most people they don't appreciate it until it's all around them, and then they still take it for granted.
And yet people love to say they support the underdog, but they like to support the underdog once they've made it.
Yeah.
Yeah.
Yep.
It's like there's a Neil Young song. He said 100 points. Everybody's holding up their lighters, smelling. He says 100 points of light for the homeless man. He's like up there. He's a star. He's playing for everybody, but he can't make his rent. And people don't really give a shit about it. They don't care about him. They don't care about the technology. They don't care about anything.
You raised an interesting comment when you said that was it Orville was the one that was in court. Isn't that also the case with Graham Bell and also Edison?
Some of them committed suicide.
These guys
Pretty much
were
any
treated
inventor.
really.
Yeah.
I mean, they had hard lives after they,
Nikola Tesla
Died penniless, mostly.
It's a tough gig, man. You might want to consider
Yeah.
going back to music.
Yeah,
not be
easier to
as
make
hard.
money. Yeah, but really, maybe quite literally.
I'm, of course, totally kidding
Yeah, but the thing
around.
is, with music, every third person, not third person, but every whatever it is, 50th person wants to play, and I don't know what the numbers are, but
here it's 50-50.
everybody loves music, you know what I'm saying,
Yeah.
and everybody wants to try a little bit, and some people are capable, and can play in venues and so on, but it's just hard. But there's a lot of competition. You know what I mean? And you have to practice all day, every day, and that isn't even that in itself isn't enough.
Yeah.
Right.
That's one thing. You
Whereas
don't have to
with
worry
this-
as much about competition for
right?
you.
Because
It's-
hardly anybody's ever even heard of this. you
Yeah.
know? So if I just do it all day, every day,
You're going to be by far and away ahead of the rest.
you're ahead of, because there's nobody doing it all day, every day that I know of. I mean, must be somebody, but
I really don't think so. I mean, again, maybe people...
They
at
never
MIT
heard of it,
Yeah,
yeah.
right.
And MIT does it for 2 semesters to get their credit,
Right.
or something. And maybe the professor did
Hey,
it
we can.
for 5 years, and then tries to not mention my patent, but patents. I have 2 patents. So, but it's there's not as much competition as music. Music's really, If you can do music, you know.
Well, even with music at the highest of levels, I don't think it's what it used to be. Again, a lot of it's now you're making money from touring, right? And it's like a lot of people, like even the highest end musicians, that's not a life for most people. Even like with the money that you're getting, a lot of that's
Right.
going back to just cover the cost of touring.
Oh yeah, the cost
especially-
is touring's worse than
insane.
the
Yeah.
income. You know.
A
And
lot of
that's
that's
what-
just because
sometimes.
the distribution's been solved so much that you could just get it on your
phone, right? So like the actual listening to music is free, which I think most
Yeah.
consumers could agree is.
How
like
are they going
yeah.
to make money? It's all free on there.
Right.
Like, any album, you just type it in for free.
Yeah.
Where's the money coming from? You know.
And yeah, it's like going out those live experiences, but then you're starting out and you're dealing with a lot of shit for no guarantee of money, maybe making a little bit of money from each show, but even the guys that or the bands that make it,
Now I could make millions of dollars from this, or there's a multi-billion-dollar industry in drones,
yeah,
and this could turn into is silent,
yep,
and silent drones aren't, this is the quietest drone, right? And theoretically,
So you mean drones powered with this technology?
yep.
yeah, drones powered. Drone may be the greatest word because it doesn't make a droning noise, but flying
But,
machines,
autonomous
Yeah.
robots.
yeah, unmanned aerial vehicles, UAVs. Silent UAVs could turn out to be worth billions or millions. But the thing is, I have to make you saw the very lightest version out there. That one's a little too fragile for public use. It's just going to be for a
It's
show.
kind of like we start doing something and we have a vision of what we see
Yep.
and what we're shooting for, and then when we get closer to an end product, we realize that it wasn't the way I envisioned it. It turned
Yeah.
into this over here.
It has to be
Like,
changed a little
Yeah,
bit
it has
of
to,
time
and
until it's
we
right.
either make a decision we're going to adapt and go that way, or we'll hold on to a vision and keep going. How do you find yourself?
It's
I mean,
like trying on shoes until you get to the right pair, that fits right. So
that's part of life in a lot of ways. I mean, Jagger said you can't always get what you want, but if you
Yeah.
try sometime, you just might find you get what you
Right.
need. So
Right. So yeah. So I mean, if if I can this next step, if it works, my newer experiments after you guys are done seeing it, what I got going now, I'm going to try to get maybe 10 times more efficient.
can you elaborate
Vehicle.
on any of that at all?
That I can't talk about because if it works, I'm patenting right away if I can. I have a friend, a patent lawyer, who did these other 2 patents. And,
So you have right now 2 patents?
2 patents. They're both pro bono patents. So I only have to pay the patent office every few years.
And real quickly, what are those again? It's the onboard,
self-contained ion-powered aircraft,
right?
which I probably should have called it propelled aircraft, but well, and then the later one is called the ion-propelled vehicle. And the ion-propelled vehicle, I knew that MIT was experimenting with gliders, but theirs didn't fly yet in 2017 and in 2016. So I thought, well, just in case someone wants to use my technology to push something horizontally, it said my first patent is for any ion-propelled vehicle that lifts its power supply against Earth's gravity. Right? So that pretty much covers anything that flies around with the power supply.
Yep.
And it was hard to get that approved, but I explained that nothing's within everything's 1,000 times too heavy, the power supplies,
Yeah.
so this was a big breakthrough, efficiency wise. So that was the first patent, right? And then the second patent spells it out, anything, whether it's vertical or horizontal, even if it's in space, if they're using all these improved things, details, all these details on a spacecraft, it also applies.
That was actually pretty smart. Do like vertically or horizontally, and then someone will be like, "Well, in space."
Yeah, so I added that on to the second patent.
And you could get a call, I would think, from NASA and say, "Hey, we need you to come in." Well, you've worked for NASA, right?
Well, as a NASA contractor, yeah.
NASA contractor.
For 5 weeks, yeah.
But you might get a call one day. This is like from the movies. You might get a call, and we need you to come to NASA HQ, and we want to talk to you about bringing your technology into.
I would enjoy that, but I would like a little bit of a licensing agreement of some sort.
Oh yeah.
The contractor didn't want to do a licensing agreement. So I said, well, okay. I was going to give them a really good deal, like only a few percent, And they said, no, we're not doing that, So I said, okay, well, you know, I'm
Don't
not going
use
to give you my patent, you know. They wanted to have the patent, so no, you know, I mean, they got to
Play ball.
work with me a little bit. I'm
Absolutely.
not asking for a lot. I'm not being greedy. I'm just, you know,
Yeah.
I just want something, you know.
Some
25
tangible
years.
25 years of your
recognition.
life.
Yeah,
25
all-
years
with-
working for free, I should get a
Look
few
at all
dollars.
this research you've done, and I mean, yeah,
Yeah, and that's just, you know, like, it's just,
that's
it doesn't
kinda
look like much, just to me, but
one
but it is a
page
lot.
of that note. I mean, one page could have been months of work, I would think.
yeah,
Or, you
I
know
mean,
what
before I did years before I even started doing those, you know.
Now,
So,
going back really quick to some of the materials that we talked about, for me, and I think a lot of other people that may be listening, they hear like nanotechnology, and that's like some ethereal, like, what the hell does that even mean? You know, people have heard about it maybe in like the Iron Man suit, you know, in some of those new like Marvel movies, like it's like basically building itself out of like thin air. So like, is that nanotechnology, or like what's nanotechnology as it like stands today, and like what's the future of nanotechnology as you understand it, and how
Well,
it applies to Ionic?
I don't know about like, you know, assembling things and all, you know,
Yeah.
things that assemble themselves and all that. I
Yeah,
don't know.
that seems very
That's not
manufactured.
something I know anything
Yeah.
about. But you know, I did see a video the other day about how microchips are made, right? And it shows these $100 million machines, and you know, a whole bunch of like huge blocks, you know, and then and a bunch of little like robot boxes that they put the chip in, and it you know, transports them from machine to machine, transports the the wafers.
Yep.
And you know, you have like the whole city of New York on, you know, it's as complicated as the whole city of New York on a little segment, you know, that's like a few 2 millimeters square or something, you know.
Yep.
And the amount of zooming in that they do to make those circuits is astonishing, you know. And you know, they're going to have because of that, AI is going to be, you know, amazing soon. It's supposed to get better 4 times every year.
And so nanotechnology is like, you understand it, or as it is, it's basically just the same process, or like the same sort of materials that are used within semiconductors. Or,
It's just a computer, right? It's just but the thing is, well, it's a computer, but I think it's programming itself, basically, sort of, right? And what's his name? Wozniak.
Yeah, Steve Wozniak.
He was saying that this new stuff, it could be base 44 he's talking about, that makes, I haven't used it yet. I kept meaning to Google it. I haven't
I'm
gone
not
there.
familiar with
But
that.
it's a program that makes programs for you. You just tell it what you want it to do, and it programs it for you.
See,
And
that's
you put
what,
your name on it, you know.
Yeah, that's our lead electrical engineer and I. You know, we've used some AI like ChatGPT. Actually, we were working on a custom drone project where we needed to deploy clam and oyster seeds from like a large,
Wow.
well, not even clam and actually like full size clam and oysters from like a large crop spraying drone.
What a great idea!
And we needed to like control this gate that could like lower down, you know, when it gets to a waypoint, so
Yeah.
the clams can start dropping off, and then as it's flying, continue releasing the clams, and then once it's detected that it's empty, then it automatically like closes back the gate and returns back to landing. And we were able to use an Arduino, like an Arduino Nano Every, and use ChatGPT to generate the Mavlink code, or basically like the radio communication protocol code to say, hey, set this delay, and then once it's closed, you know, after like the 5 or 10 seconds that it needed to like close all the way, then trigger the return to landing. So then it goes back to where it took off from. It can be loaded back up and then resume from that mission. So I mentioned that as like where we've been able to use AI already in some of our development.
It's like high level
Yeah,
stuff.
and again, he's an electrical engineer. He's done some Arduino coding. I've done some Arduino code modifying, and it.
Coding.
Literally, it did something that neither of us were able to do, you know, by ourselves, at least within a reasonable time frame.
Takes time to do that stuff, yeah.
And then, you know, it was able to get it the first attempt, right? And then we started talking about how else like could AI, be applied? And the way that we are most excited, turns out Jensen Huang, the founder of NVIDIA, is also most excited about this. AI for electrical board design for, PCB design. That would be huge. Just like, here are the capabilities of this board. Maybe here's the form factor. Maybe I even know a few components I need, and then you figure out the rest of the components, the layout.
One of the things I like, though, is that I noticed AI, they say AI can hallucinate things.
Yeah.
And it starts hallucinating after a while. If you have it draw you pictures, it can start just messing up. And I spent all night one time fiddling with it, and it kept messing up on me. It started getting like crazy on me all of a sudden.
Yeah.
And there's some things it doesn't do well, like
sometimes
it keeps promising you, just wait, I'll have that ready for you right in a minute, and you wait and nothing comes, and you do it again and again and again, and then
please try again in 24 hours.
And it just goes into like a mental breakdown mode or something, and so you really have to like. It's AI has a mode where it just doesn't work right,
Yeah, it's very.
You get stuck in it, Yeah. So other times it's like, wow, man, you figured that out already. Rewrite this, so it makes sense, to the normal person, and it instantly does it like it was nothing, And then you try something like what you're talking about, and it just can't get through it, just keeps you tied up,
Yeah, we're doing some troubleshooting with our drone control software to where. You plug in a game controller to the computer running our software in the web browser, and it's basically just sending a repeat input to tell the drone to land, which we're not pressing any buttons, providing, and you would like to be able to use ChatGPT to kind of understand what's going on there, what parameters but then it kind of breaks down there.
And all this stuff has to be like reflex, It can't be like you can't. Processing, land over here right now without crashing.
Or
processing, we'll get back to you. And
it would be really great. Hey, monitor what's going on in my screen. Also monitor this video where you can actually see the drone corresponding to what's happening on my screen, and then diagnose, and that would be ideal, right? But I think we're quite some ways from that. But I would like to get to a demo, but. I have your website pulled up here. Maybe if we could share this briefly.
Sure.
If anyone would like to get in contact with you, whether it's collaboration, maybe work or investment, right? This is probably the best way to find you. Going to Electron Air, electronairllc.org.
Yeah, .org, yeah.
And then, of course, you have a YouTube channel that you have tons of public videos out there.
45 public videos of it flying,
Anywhere else that people should think to reach you or get in contact you? Anything that you're looking for?
Well, my phone number's on this website, and it's you have to leave a message because otherwise I get too many junk calls, and
like from me.
Yeah, no, you're not junk call. No, you're important, but So that's my phone number right there for anybody to see, and you can email me through there. There's there's a drop down menu or something that shows the contacts. Okay, contact box and a phone number, right?
Yep.
So that goes straight to my email, and so I'm easy to reach, and there's all kinds of, like I said, videos, all kinds of data, and regularly asked questions. Commonly asked questions like, does it produce ozone? And in the case of the vehicle I have, it's got such low current that it doesn't make any O3 molecules. It just adds a little bit of static to the air. So it's not, doesn't create any compounds.
We are living in the Wild West of aviation, and it's just so cool to see where this is now. That it's obviously not been overnight to get it to this point, but just seeing the progression of it, even the last few years that I've known you, and then seeing where it's
the lightest flight controllers then were like 800 milligrams, but there's usually a little extra just for to have a accelerometer and gyro. And now I have all the sensors, and it can do it at, for a few hundred milligrams.
So if someone wanted to collaborate with you from some other location and kind of go into partnership with you to share ideas and work on the same you're open to that.
Sure. Oh yeah.
So what do you call that? Kind of like a crowdsourcing idea, but much smaller, because I think there's not going to be a huge.
Yeah, I mean that almost to me like, and it's not open source, but it almost seems like again like an open source. Like, hey, here's what again you do put out a lot of information out there that people can learn from, and like again. The name of the game with the patent is you're literally like saying, this is what I've done and this is how you can go, like now you can't go commercialize it, right?
Right.
But you're still out there to give people
I don't care if someone wants to, replicate this. Technically with a patent, they're not supposed to copy what you do or anything, but I'm like thrilled if someone makes one quite similar. Yeah, if they make one quite similar and they get it to fly in their garage, and they show, look, man, I just copied Ethan's thing, and it works here. Flew for 2 seconds, or they say, here it is hanging from a scale. It's got 98% lift.
Yeah.
I'm thrilled about that. I mean, I don't mind that. But if they're a company and they're getting $8 million contracts, and there's and they're, hey, thanks, Ethan. I appreciate all your work has really helped us out, man. We're doing really well now. I'd appreciate a little bit of kickback there.
And I'm thinking along the lines of some aspect of what you're working on, someone focusing on to take that off of your plate. One aspect of the where you see whatever, because I'm sure you've got several things.
I'm working on the steering versus I'm working on the transformer versus I'm working on the collector surfaces. Or
that to me, that's kind of what I'm thinking. That way,
to give them help. You mean?
Yeah, that way
consulting.
You're all
sure.
able to work together to try to.
I'd like to help people. To consult. That's what I was doing before. Was consulting for a NASA contractor, and it's just they just didn't want to do any kind of agreement to licensing agreement of any sort, but I wasn't much that I was asking for, so, but I'm glad to help people whenever I can, and I don't want to live and die, and I want to get further along than this. I want to get something that's commercialized. And one guy told me I should sell services instead of just crafts, right? Like silent flight, they could rent it for silent flights, or go to this into space, carry a tiny camera, take pictures in space or something like that. And I think that does sound like a good business idea. It sounds like it'd make a lot more money, because if someone can go buy a quadcopter for $20 at Walmart, why are they gonna spend a lot more to get one that's silent? That's more fragile and larger. It may be that, in the future, this could be much cheaper than a quadcopter.
Right.
Because it doesn't have to have gears or any of that, right? And I'm going to make the steering solid state in the future, another thing, if I can. So right now it has 2 little switches, but, and I did, for the yaw, I did have twist fins for that system. So that may require that, but we'll see.
Well, Ethan, thank you again for welcoming us and doing this podcast and doing the tour. And then if all goes well, knock on wood, right? We'll have a demo as well.
Demo, sure, yeah. Let's fire it up,
Awesome. Oh, thank you.
Thanks.
Bless you guys. Thank you for
everything.
Yeah. All right.
It was all autonomous humanity on assignment. Dun, dun, dun. We're in Oberlin, Ohio.
Okay, so here's some early, very, very 2000,
Oh, wow. Yeah.
So there's the carbon rings.
Yep.
They had needles over them. Here's one with bigger rings, right? But you got to have round front sides on the rings. You can't have, sharp fronts on them.
Yep.
And then the very earliest things, though, one of these is, see, this is made of a bunch of triangles with needles. Here, don't break it because it's like history. Yep. So I made a triangle like this out of foil, and then you cut 10 holes in it, 3/4 inch holes, right? 4 1/4 inch triangle. Right.
And what were you doing to cut the holes out?
A big pin.
Okay. Wow.
You ever done that before?
No.
If you put a circle template on it and you write around with a big pen, around and around with a ballpoint pen,
And it'll just cut
it just
through
pops
it.
right out. Yeah.
Okay. Wow.
So you do that, and you put 10 holes in like that, so it's mostly air, right?
Yep.
And then you put a T-shaped frame under here, right?
Yep.
And then I put a long stick, and one of them had a real thin stick that was like 6 feet long, and one of these triangles was picking it up.
Wow.
You know, it
yeah.
was really a thin stick, but
Yep.
out of balsa, but still a 6-foot stick, I could say, you know, honestly. And then I put this little plastic post. It was from a pen, ballpoint pen, you know, hook.
Yep.
Right? Put that on there, and then I got this little blob of a wire from a screen door, right? And I put it on top of there and put a little loop in there. You see the loop? Well, originally they had a little loop, right? Like I twisted it so there's a loop on the end.
Yep.
And then you put all those needles so they hang right over the top of each hole, right? So you get an ion point source over the hole, and then it blows air down through the holes, right?
Yep.
And then with an external power supply, I had one of these little triangles that would, you know, jump up in the air with a 9-volt battery to power it,
Right.
capable of 10 amps. Right? And it would go and jump up in the air, and everybody was all amazed, right? And then I thought, well, I'll put all these together and make like a flying saucer-looking thing. So I put, was that 6 of them? 1,
Yep.
2, 3. Yeah, I put 6 of them together to make this. It could carry a thicker stick, you know, and it would fly around. And I did that was in 2000, right? With a big, you know, larger external power supply. So, and then like, you know, here's a few extra things. But there's so many of these, you wouldn't even believe how many different types of iterations. I just didn't throw that away because it was an early, exciting success. You know?
And what's the story behind that one?
This?
Yep.
Okay, I had to make a smaller one to fit in this vacuum chamber.
Okay. And
So I
just
made
doing
this
vacuum
for
testing.
the vacuum chamber, and it has a tube that comes down, and it had irrigation tubes over the top. I don't know where it went, but oh yeah, it's right here.
Okay.
You see, it looks like a spider here.
Yep.
Like spider legs.
Yep.
That plugs into the top, or did plug into the top of this one, and then these tubes have little holes in the sides, like irrigation tubing, you know.
Yeah.
And so the oxygen comes in through the tube and blows down over the vehicle. And that serves as a propellant to test it in a vacuum. But what I didn't know is that when you put something in here, it stops all the air from going in through the sides, right?
Yep.
Because the sides are covered. And also, when it's in this little chamber, the air can't start flowing like this because it's bottled up.
Yeah.
So it stops the lift. It doesn't have to be pumped down. It stops the lift, you know. So the only way to do it would be with a little tiny one in this chamber, or get a real long vacuum chamber.
Right.
Right. So there goes thousands of dollars. Well, I mean, it's still going to make it work. I'll just use a small.
That, and I mean, you wouldn't have been able to find that out without, you know, doing the test. I mean, maybe theoretically you could have done some sort of complex math, right?
What I mean is you just don't get force
Right.
at all, even when it's not pumped down at all.
Well, I was just saying, like, in the sense that, like, this isn't wasted thousands of dollars because, like,
No.
it got you new information,
Sure,
right?
right.
That, yeah.
Yeah, I don't mean it. I
Right.
don't mean it because I could still do tests with it. I just have
Right.
to. Just
Not
have
for
to
this
use smaller.
specific one.
Not
right.
for that specific test model. But yeah, I just use a small one.
Holy cow, that ant, what is that carrying?
Oh,
A
geez.
spider.
Is it carrying a spider?
Yeah, that's metal. That's awesome.
Freaky. That's that superconducting wire I used to. I had a 6-foot one in a garage in 2003, and this company sent me this superconducting wire for free. It's an American superconductor. So I made a transformer with it, and it really made a powerful transformer. And I had to get a dewar full of liquid nitrogen. I was pouring it in. It was.
This episode of Autonomous Humanity is brought to you by American Semiconductor.
Yeah. What's it called?
We're not supposed to be doing that.
American-
We don't have any-
Yeah,
Superconductor.
superconductors.
American
American superconductors. Yeah.
Yeah, and then I have another thing of a thinner diameter wire, but it's for only for liquid nitrogen, and it has to be heated to like a certain temperature so the chemicals melt properly in it. And I never could get a good directions on how to do that, but now I think I can figure it out, you know. But
Yeah.
then I got to get liquid nitrogen, and it's not practical, you know, for these things. But yeah, so that's how that works. Now I got to go check those batteries.
All right.
And then glasses. Okay, and I'm gonna now. Last time I flew it on the camera, I saw that I sometimes forget which, but it's this one. It works, it's programmed properly for that. Should be. Okay, I'll put this. This is this extra spare pack. So this one's a power hog, and it's seen better days since the fire and all. Could be better, but okay. I'll just I'll take those.
Ceramic tweezers?
Yeah, they're plastic tips, so they don't transmit the shocks. And I was going to check it since I moved this and I grabbed it and moved it to put new paper down. I want to make sure that I didn't bump any wires loose.
Dun, 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 dun,
Oh
dun.
man.
And they all look good to me as best I can see. Okay, so I'll plug this in and turn the receiver on afterwards. Okay, and make sure the batteries are on properly. Too high up. Hang on. Okay.
So the official name again of this?
Ionic wind aircraft.
Ion propelled vehicle.
Okay.
It's blinking.
Ethan Krauss.
Yeah.
Ionic.
Ion propelled vehicle or self-contained ion powered aircraft. Okay, here we go. The light went out, which is healthy. Here we go. A minute.
Got
It's
some
sticking a
left.
little. Hang on a second. Shoot. Hang on.
That is so neat.
Shoot. That's the light's coming on. It means there's a.
You should always
Means there's a.
double check the lights very often.
Yeah, that's right.
Especially with the
Wow.
There. Okay, it left the table. And it wasn't quite as vigorous as last time. Let's see. Let's try.
It's like watching magic happen in front of your.
Well, I've had much stronger flights, but
batteries are all good.
yeah, I don't know exactly what's up with that. I do have an extra set of batteries, so in case there's a way to fix that. Maybe we have a ring disconnected, or I don't know what's going on with it. I mean, you can see it works, you know?
Yeah.
But these gold ones have always been not as good as the silver ones. Trying to shut it off.
I don't know if this mic is going to catch that, but I just love that. I mean, it's such a minimal sound, but.
Okay, it's not quite doing what I want. Let's see how warm the batteries are getting. Fairly warm. Oh, maybe the batteries weren't plugged in as good as they could have been. Let's try it again. No. Okay, let's try it with other batteries. It took a minute to de-energize. I probably need a little bit bigger gate resistor. Okay, let's try it with this other set.
I've said it before, but man, does this look make our demos look like child's play?
Thank you. No, you're doing interesting stuff there. It's high level, you know, with well proven, but thank you, babe. I got it. Thank you, though.
I remember your first drone flight. I think it was on the 4th of July.
That didn't fly?
It didn't fly. It was so hot, and God, it was burning hot outside. And I actually walked down and found some shade to stand under. But
Yeah.
I know your dad was sitting there, and he looked at me, and someone said, "Well, something might go wrong if we do that." And Jeff goes, "What could possibly go wrong?"
Nope. Hang on a second. No, it's doing weird stuff. There. That's a little
Wow.
better. I don't know what's catching. But well, there's a bit of a power
Something about
drain.
the opposite corner, 'cause
You think?
these are
Have you heard
going
something?
Up, lifting up, and the other one is drooping.
Hmm.
Maybe we check some.
Okay. Thank you. Don't know why they've shut the receiver
This
on and off.
half of it looks like it's being activated, but that side doesn't.
Maybe it's only getting one side activated. Yeah. Well, I really don't know what to say right now. I don't think I can fix it like instantly. You know what I mean? Like it'll take time.
Yeah, I very much understand that. And again, I get that's more for the camera viewers, but just again, seeing this in action in person, I mean, is so surreal. I mean,
It
yeah,
really
looks
does
like
work.
magic.
You know?
Yeah,
It's just
very finicky.
another
A lot
thing.
of-
Yeah, sometimes I can pull it if it's flying one direction. I can pull it the other direction with this tie down. Didn't work. Nope. Nope. Okay. Well, it wasn't the best flight it's made.
Before this way.
So
Do you wanna try to fly that one?
I think we could. I have to plug in the power supply though on top. I have to plug in the inverter and two wires to the voltage multiplier and one to the emitters.
So you're saying it would take more time?
Well, it's that one has half as thick a material, so it's very fragile. We could try it.
I
think
don't
it's
want to
worth
push
it.
you. Yeah, I don't want to push you to break it, but if you're
No,
up
I
for
think
it,
I'm up for it. I think we should
Okay.
try it.
the entrepreneurial way. Fuck it, let's send it. If you're familiar
try
with Bill O'Reilly, fuck
Oh,
it, we're
yeah.
doing it live.
Yeah.
Do you wanna remove the batteries?
Oh, did I? Oh God, I almost forgot and left the batteries on there. Thank you. What I do
Behind
now-
every great man, there's a equally great, if not better, woman, right?
No, you have no idea. That's true. So, I mean, usually I, come out when it's quiet and I slowly put everything together, and sometimes it's stressful. I don't like the way that bottom plug is kind of not in there really that firm. It is in the hole. It's just, it should be seated all the way, Probably what I would do is, probably what I should do is put a little dab of some glue that has a fairly thick consistency and glue it there so it doesn't come out easily, But not enough so it wicks in there. I mean, it has to be thixotropic enough, they call it, non-run enough so it doesn't get wicked in there,
Right.
Some sort of a thick glue, and that way that will stay put. I also have to check and make sure that I have the plug wire, the plugs facing the right direction. So the for the jumpers. See the jumpers, right? They're facing you. You see them?
Yeah, here.
So yeah. So usually there's an F on the well, it's too late for that. So this will be the front. So let me mark that.
And then, I do see one of the jumpers coming out over there.
Yeah, that's the. Wait a minute. Why is it on that side? Oh, that's the jumper for the top. Yeah, the top has jumpers. So this is the F. Okay. The front doesn't look good, does it? Looks like a bad grade on a paper. I hate that. I don't know. I'm sorry. I'm not usually like that way about things, but I just don't like that.
It's gone on your permanent record.
Yeah. This cannot be this. This one has to be an A, not F. I should change it to A just for
Yeah, what's
superstition's sake.
what's the opposite of aft?
Oh, F. 4.
Okay.
Still sounds like F.
Yeah.
Aft and forward.
This will probably. I can't even get it open. I have all my markers are brought inside.
Other than the red one.
Well, how about this? I got an idea. I don't want to be ridiculous about it.
There we go. Yeah, arrow.
Okay.
And there's
Okay.
a will, there's a way.
Enough silliness there. Okay, so now the next thing is that thick glue I was telling you about. To pick one that. that
Maybe to your right, red cap or black cap.
Upper shelf.
No, those no, not that. I think I can find it. I will find it. Hang on a second. I had it all sitting out actually here. Well, sometimes I spend more time looking for things than working, you know.
That's our office as well.
You ever been that way? You ever been there before?
Many days a week.
Yeah. So these.
Grease.
This
Is
one's
it a
probably-
white glue?
No, this is the stuff probably.
Okay.
But it may say hypo cement in there.
Now, what about the stuff
But I think it might
right
be
there
empty.
on the table?
Yeah. In fact, there you go. That's it. Thank you.
They call me Bloodhound.
I'll put this
We do.
there. Okay, this.
Or no, hound
Wait a
dog.
minute, this one. There's not another one of these? I thought there was a thicker one.
Just the one that was right next to it.
I don't know if this is any good. This is old stuff. Let's see. Ah. Okay.
Please don't slice your finger open.
Yeah, hey then. It'd make for a more interesting video, wouldn't it?
Can't post blood. Blood
Mhm.
or violence.
Really?
just that
Oh
one.
no. The computer will think I already have a blocker video with my red paint on my finger. This is too thick, I think. This one's garbage. Hang on. I gotta find a little that's in decent shape. This is kind of pushing things, you know what I mean, to try to get it to fly as is, because the emitter wires are not adjusted. Okay, this is okay. Just need to get it.
In the right spot.
Yeah,
Easier said than done.
yeah. If I had a stick, a balsa stick, or a a piece of boron would be better. Or whatever this is, carbon here maybe. Piece of carbon. This is heavy carbon, well, compared to what I usually use.
It's like the equivalent of our little wooden stir coffee sticks that we use in the office to apply glue.
Oh wow. It's getting ridiculous.
This is like level 100 carnival game.
I don't know if that came off there. It's kind of dry. This glue is kind of awful thick. You know, it's like seen better days. There's some that might be thicker. I don't want to put too much on, or I won't be able to get it off of there. You know. Yeah. Shit. Okay. I never did check to make sure that that thing's right. I still have time to do it.
Push it in.
Well, no, I have to make sure that the
It's connected.
voltage multiplier is, the two pins are are parallelish with the jumper, you know, with the upper, what do you call it, jumper wires? Let's see. I think I got it. Yeah, it's good. The two pins here have to be facing like this
Okay.
because the high voltage wires come down and plug in here and there. And then this has a little outlet where that'll plug in. You see? So if they were like this, it would be bad. But they're right. So that'll be drying. And then there was this end here. Oh, it kind of fixed itself. Well, not really. Because that's there. That's the only reason. So this side I was going to put a little piece of plastic on it. Ugh. See, there was one on it already. It's not there anymore. Sheesh. Okay, let me get a little different glue. This is thinner here. I don't know if this is going to fix it or not. And this will probably come out. So this is probably not the most exciting video in the world, depending on. Here we
Here
go.
you are.
Yeah. Yeah. Hope I'm not too mad. Past a certain point, it's just sad. Okay, but anyway. I think maybe I see a problem with this, maybe. That's not too, I mean, it's better. Could be better, but it's going to get pulled up when like this when it energizes, you know. If it all works, we'll see.
Man, that precision.
Yeah. Okay, I'll just leave this drying with this under it for the moment. Okay, so then we move over to the inverter. Now that one has a male sticking up, so here's a female. Connection plug. That's not going to pop loose, I don't think, on its own. I need to get over here, plug this in. Oh, got to get rid of those clamps too. I'll do that next. Here. I hope your camera can focus even though I'm moving around.
You want to hold?
No, I got it. It's cool. I got it. Now this has everything, steering on it, switches, you know. It doesn't have the flight controller, but as you notice, those don't weigh anything anymore.
Yeah.
So just a few more wires to be connected in the flight controller part, and this would have total steering and roll and pitch. Just the yaw fins would have to be added to do yaw too.
Yep.
But you saw
That's so
those.
awesome.
So that's plugged in there. Now I have to get to the right tweezers to plug in those plugs. So I can't use these because they're not. Those plugs are finicky. Shoot, I might have to go in to get those to the house. I have two specific tweezers that I prefer for this operation. No. Big one? No, it's not them. It's two normal, absolutely plain Jane ones. I have real fancy ones that are expensive, but they're not as sturdy, you know. For this one, it takes like fairly ordinary tweezers. shoot. I know for sure I have one ordinary one in the house. The other ordinary one, I don't know.
There's
Oh,
one
here.
that silver. Okay.
There, that's one. Yeah, that's one of the ordinary ones. I need one more. And this is some very thin plastic that I was going to use to make battens, but I am, skipping it because I want you guys to see. I want to try something. Try it with this.
All right.
So let me get the other tweezers out of from inside. I'll be back in a flash.
Nobody sneaks.
Okay.
If you're happy and you know it.
Clap your hands. Okay. Okay, with that. So. This got stuck in here somehow. This can happen. There, okay, got that. Can't see what I'm doing. No. This is a male or female there? It's a female. Okay, so I'll do this. There, male. I hope I got the other. Hope I don't have to make an adapter. That's happened to me.
You need to step back, Brian. There's room.
I don't think it's going to plug in. Shit. Dang it. Sorry to say, I think I'm going to have to flip this around, and I think I glued it, which is a big bummer. Sorry about that.
No worries.
That plug's not going to go. Okay. I'm hoping that glue won't prevent this from spinning. Let's see here. Yeah, that shouldn't be over. It should be through the back. I'm sorry, but let me double check here. But I think that so this is a female or male here. That had to be female. I had that twist. It's twisted 180 degrees. Let's see if it's not glued too much to twist again. I may have put too much glue on it. I thought I had it. Another option is I could take that off and swap these pins. And then it shouldn't have created any problems. Maybe, probably. It'll probably be all right. I think that's safer. Okay, I'm going to switch the pins on this inverter, okay?
All right.
That's because now it's too late to. I think it'll be all right.
Past the point of no return.
Yeah. And this battery swelled a little bit. It was that other Honocraft is on propelled vehicles just hogging power, Okay, so or I'll just put it on this. Okay. I'll swap these plugs. And see if I got, this is probably regular solder. Where does it say? There. Tin. I don't think this is tin lead. Well, I can make it work whether it is or not, but I prefer leaded solder. I think it's leaded.
I don't want you to feel like you have to do this for us. Like, I don't want you to, like...
Oh, it's okay. It's okay. It's not a... I mean, I want to test it myself. What I'm worried about is if it collapses.
Right.
It's going to be like, oh, man. You see where is it? The arrow.
The arrow is here.
So the plug should then be here, but I don't see it. I might have screwed up on that. Where's the plug hanging down? It should be right here.
Yeah.
Oh, that's not the front. This is the front. The front's on the right place. Oh, okay. I need to erase that, but I'll do that next. Oh no.
Does that mean the swap you did was...
Yeah, the swap I did was a dumbass thing. Okay, well, it's all cleaned off now. I can swap back easily enough. I'll do that, okay?
Okay, yeah.
Yeah, it means the swap I did was it? Oops.
Product development overseas, and not that we can or should bring all of it back onshore domestically, but
How can I have done it wrong? I think I did it wrong again. It's wrong still.
The front's now over.
Yeah, I moved the front there, and the jumper's right there. So it should go like this, and there should be a male on the left, but there isn't. So I'll do it again.
take three, third time.
Experimental model. Okay, I'm gonna go like this. Should work. Okay, got that. Now we do the drive wire. Hard to believe all that power goes through these, huh?
Yeah.
All those volts. I could put millions of volts through these. Oy, this is really kind of scary. I would normally use a thinner tweezers to try to fix this. This has got me worried, but we'll see. We don't know. I can't promise it, but I pray. That's all. Say my prayers. What else?
You've already delivered far more than what we could have hoped for today.
Well, thank you. Thank you. Appreciate hearing that. There. I got it. Okay. 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 Now we got to find that.
That has great built-in audio anyway. But
Okay, where's the female? Shoot, I can't see it. I might have to switch over to 10-inch focal length. There it is. It's on the inside, I think.
Yep.
Oh! I got to put it back in there. Shit. How that happened, I don't know. Okay. Okay, it's plugged in again. This time the plug's facing forwards. Here's this. Seems to be hooked up. Maybe.
I feel like it can be like easy. Okay.
I'm nervous just watching.
It may be all right. This should be not down this low. That's a bad thing. There. It's not great, but it's better. Okay, I think as ready as it'll be. Maybe. All right.
All right. Yeah.
Let's get rid of this stuff. I don't want to short out my hygrometer thing. Or moisture meter, you know, whatever it's called. I think it's called a hygrometer, isn't it?
I think so. Yeah.
Temperature. All right, so. Okay, thank you. And I had a glove, and I had a glove and a plastic tweezers. Here's the plastic tweezers, and here's the glove. So the right, yeah, okay. So this is a first, all-time first. I don't know.
Hear that just for us, all time first.
Yeah.
This is really cool. I appreciate you doing this. And I know it's not easy putting yourself out there, especially when it's the first and not previously tested.
Yeah.
I know how fun it is when it does.
So if it collapses, you know, look, try to put it out of your mind, you know, please. Okay. Oh.
I mean, to me, that's almost as cool. Like, you know, imagine seeing one of the Wright brothers' first flights, but like you see one of their crashes. You know, that's just as cool story. I mean,
You've seen the footage of all the earlier planes trying to get them off the ground.
Yeah.
Now, one other thing, you don't want to be too close, or the arcs can jump over to you. So.
Please.
Zapped.
Yeah.
Jacob's had it coming for so long.
No.
Ow. Basically tases himself. That'd be great.
I think the best way to move this is to go like this, dangerous as it is. Well, no, I mean, normally I just pull it, scoot it over. And this shouldn't be there, these bits of carbon. That's carbon there that weighs nothing. This one, when the light stays on, the receiver's happy. Okay. I hope that the plug on here, I'm a little worried about that multi-plug. You see any wires come loose or something. You come the right way on that. You know, because it was sort of.
Just flies at us and tases us.
Much rather this fly ass than develop air. Or that could be me being very naive.
You see any light?
Yeah, I thought I did. Right? Oh yeah.
Yeah, I see.
Oh, okay. This one has to be. This has to be on. Wait, no, the light has to be steady. There.
There you go.
Okay. All right, let me take off my glove. I prefer to.
Raw dog it.
Now, it could just go. We don't know. What
Yeah.
Ready? Like I said, the power draw was too low. I think it's not drawing enough power. I'm sorry. Unless something kicks all of a sudden.
We got movement.
Yeah, it needs to be. The inverter needs to be taken off and checked. Sorry.
No, you're good.
No, this is
Still, yeah.
Ethan. This is leaps and bounds. Like I get in the same spot, but this is still leaps and bounds far ahead of what anyone else is doing. So the fact that we get to see it in progress like this is.
But I mean, this whole thing is 7 grams lighter than the other one. You know. Oh, wait a minute. Hey. Oh, wait a minute. First, we got to check and make sure none of these tie downs are where they're not supposed to be. Because sometimes they can get caught. They could just be held down. Because when it was all ready to fly, it just was being held down by something. And they're all loose. It's just not drawing on current to quite take off.
I mean, this
It's an
side's
adjustment. Did it start
taking
to?
off.
Yeah.
It's not touching the table on this side.
Oh yeah.
It's actually flying.
Well, this isn't the best. The tubes are energized too. I see that. You know what? I mean, put epoxy on the ends of these because they're losing a lot of power there. If I looked under ultraviolet camera,
Yep.
I would see probably a massive power loss in these tips. I need to put epoxy in the tips. I forgot to do that. And they are energized. I can feel shocks from on the carbons. The electricity's getting into the carbon, and the carbons have like a brush on the end of each end. So, and those little transformers don't have a lot to spare. So it's drawing. It's getting more powerful as time goes on. Maybe it'll get more powerful.
That is just so wild.
It's like that end over there is not moving as much.
Could be.
The closest point to you, Jake.
Oh, look at there.
Sometimes when I pull on it a little, it's almost, I don't know why it works, but sometimes it works. If it's not drawing a lot of power, I think it's probably, the batteries are ice cold. It's drawing almost nothing. Versus the other crap is drawing a lot of power.
The light has gone from red to like amber now. Looks like
No, that's been amber, at least from where it was for me.
When it blinks, though, it may mean a bad connection.
It's blinking a lot when you give it power.
Yeah.
Or it's just getting sensitive to the... Another thing, too, is these emitter wires, I didn't adjust them. They're not flat like they should be, because I rushed it, Well, it's trying, Also, I didn't take off the steering system. If I took, that would help. But you see, if I took off the steering system and made it like a gram lighter, it might...
That'd make all the difference.
It might fly just fine, right? I mean, you wouldn't hear anything, right? It's
Right.
silent.
Right.
That means it's working properly.
Yeah.
Well, it's one sign. That's what
Yeah.
So, it's just not quite. I mean, you saw the other one leave the table and fly
Yeah.
for sure.
Yep.
It didn't
That's on that other card that you
stay
have.
up, but it did show you that it's a real thing.
I mean, even this shows that it's real. I mean,
Yeah, it
That's-
should be. I mean, it should be, but it's just, it doesn't leave the table, it doesn't leave the table, but
yeah.
it does matter. I mean, it's like,
It's clearly responding to your input.
Yeah,
Right?
I mean, there's no way I could do it. This is a long-term thing. It
Right.
takes too much time to.
Yeah, turn around.
It's like
Yeah.
the Starship. The Elon Musk thinks he can't fix it in 5 minutes. I can't
Right.
do it.
Yeah, it's
You know?
like, no, this one blew up. We're going to be at it for another couple months, and we'll try again in a couple months. Yeah.
They tried the others. No, the other cell's not even charged. Unless I try it with a totally different cell. But I don't think that's like. Anyway.
But, hey, I know you're like probably dying inside to some degree, but like, don't, because I think this is incredible for you both to see for
I've
the
never
first
seen
time.
anything
Yeah.
like it.
Yeah,
Not live.
yeah.
Just what I've seen
His
online.
videos, yeah.
Yeah.
Well, I mean, you could see if all the emitter bars were flat. They're not too off. I mean, in terms of flatness. The problem is probably the transformer adjustment. I mean, as you see, I made so many of them. Only the best ones work.
Yep.
You know what I mean? It's pretty out of spec by 5% or something.
And whenever you get to the peak, like you go to max, that board starts flickering.
I'm not really sure why it's doing that. It could be the high voltage getting into it. It could be that it doesn't like this type of receiver much. I'm trying to.
The other thing is that might not be fully seated.
That's another thing. Yeah. It could be. At night, I could take that chrono camera, the analog one. In the day, you could maybe even see it if I charge up the chrono camera, and you can see it sparkling where it's leaking.
Yep.
If it's sparkling down there, then that means it is just a bad connection. But with the analog one I showed you, that still works. It's charged up still somewhat. They both work good. You can see it like when you put it in like moonlight level light. You come in here and you adjust the dial and stare at it, and you can see how much is leaking everywhere in each place. Because you can tell maybe it could have a slightly bad plug that's not quite seated right or something.
Hey, what's up?
That's it. You never know. It could just go boom all of a sudden. I'm not kidding.
Yeah.
You get great amounts of lift.
Okay.
When it's working right, it's
Is Mom not there?
really working right. Slow
Okay.
energization.
I'll-
Just rapid.
Yeah, it's a lens rentals box.
Yeah, it flickers once it goes to the top.
Also, the batteries are swollen a little last night. So
Yep, that's it.
maybe I can make a fresh battery pack. That'd probably make it fly good. I have a tester that tests battery
A
resistance.
pretty boy.
I will take the battery out and test the battery resistance and tell you.
Okay.
That's a quick